this is my tour of Desmos and everything you can do. It's a broad overview. I would honestly recommend watching this video, even if you're a pro, because there probably are some things in this guide that you might have missed on your Desmos knowledge. So let's break it down. First of all, the most obvious thing is graphing, okay? Let's say, for example, you have like x squared, I don't know, plus 10. What this is going to do is it will graph your intercepts. It'll graph your y-intercept and your x-intercepts if applicable. Like here, if you have x squared minus 100 or something, the intercepts are this and this. So it graphs your intercepts, your x, and your y-intercepts. It also graphs the minimum. So for example, let's say you had like this graph. It shows the minimum right here. This is the vertex, by the way. Now, we have intercepts, good. Now tables. Tables, usually you will use if you're given multiple points. So all you do is either click this little plus button and go to table, or you literally just type in table like this. So that can be like 110, 230, and then 550. And then it'll usually tell you if it's like linear or quadratic or something. But like here, it's just implied that it's linear. It'll probably tell you it's linear and be like, okay, now you just add it to a linear regression. So here, a better example would be 220. So this is actually linear regression. Now, this drop down controls like the format of your thing. So if they tell you it's quadratic, then you have to click the little quadratic here. Or you would export as a custom regression and then change it to the format. But I'm going to go more in depth on this thing later. This is more of an advanced thing. But anyway, this is how you use tables. You put in the table, put in some points, and then either change the dropdown to fit what they tell you, or use a custom regression, which is a little bit more advanced. And you can take this equation and put it on a separate line if you need to do anything further to it. But you can't copy and paste it because on the SAT, you can't use Control C, Control V. Next is going to be X and Y versus constants. So in Desmos, it recognizes X as a like a graphable variable. Whereas like if you put like C squared, it's not going to graph it because C is a constant. It's a number you don't know what it is. So if you have like C or Y or something, it's not going to graph. Now, with Y, it actually does graph it, but you have to finish the equation. Like you have to set it equal to 100. So you might see on some equivalent expressions problems, if you have like x squared equals 10, it'll graph it. But if you have like x squared times y equals 10, then it will graph it as well. But if you got rid of it, then it wouldn't have it. So if you have x and y, you must set it equal to a number to complete the equation. Some people like to set equal to y, but I just prefer to pick like 100 or something. By the way, don't pick 0 or 1 because those are unreliable. Uh, Now sliders, sometimes you'll get a blue box, but if you set it equal to like a number, like I don't know, c squared plus a equals 100 or something, it's not going to show a slider unless you add it manually. So on a new line, you'll have to type in like c equals 1. And now basically what a slider does is it assigns this number to this variable in the equation. So for example, let's make a new example, c squared. If you said c equals like 10, then it's going to register c as 10, and then it'll solve for this thing. And then sometimes it'll graph it. It's like c squared x. Now it actually graphs the equation because we know what c is. Like I said before, it'll sometimes show a blue box, but if in some equations you'll have like equals 100, and it's not going to show a blue box, so you have to type it in manually. I would just like practice typing it in manually because you're not always going to get the blue box. It's just not that common. Now, second, it's just like the slider boundaries. So if you set c equal to 1, you can change the boundaries of the slider. Right now, you can only drag it up and down to -10 and 10. But if you click on one of these numbers here, you can just like change the bounds to like 1,000 if you want. So now I can actually drag it up to 1,000. Whereas before I could only go to 10. You could also use the step. So the step is what basically controls the amount of numbers, like how much it goes up per drag. So say the step was 1. Every time you drag it, it'll just go up or down by 1. Whereas before, if you don't have a step, then it's going to use decimals. So for example, if it told you that c is an integer, this is a very applicable thing. If it says c is an integer, I'm going to set a step of 1 because it must be an integer. Therefore, it must go up by 1 or down by 1 every time. So this is step and boundaries of a slider. Now moving on, we have stats functions. This is like if you have a list, let's say 1, 2, 3, 4, 5. You can find the mean just by literally typing in mean. So mean, there you go. Also, all these stats functions, if you forget any of them, go to functions on this tab and then scroll down to statistics and then some other stuff here, which I'll explain later. But you can do mean, you can do median, you can do standard deviation, which is just STDEV. By the way, this is very helpful because this is very hard to calculate by hand. I do it in Desmos every single time. So STDEV for that. Now you also have greatest common denominator, which is helpful sometimes, GCD, and it shows the greatest common denominator of whatever you have. So let's say you had like, I don't know, 2, 4, and 6. Then the GCD will be 2. Perfect. You could also do greatest common factor, which in this case is going to be the same thing. But I don't know, let's say you like 4, 40, and 60. Now your greatest common factor is 4. So this is pretty helpful on factoring problems. Next one is LCM, which is least common multiple. This is not really that applicable, but you could technically use it on some factoring questions. I've never personally used it on the SAT, but just to keep it in mind. Now, last one is modulus. So modulus is basically finding the remainder of something. So for example, if we divided 5 by 2, we're going to get 2 with a remainder of 1 because 2 goes into it twice with a remainder of 1. You can do this in Desmos, just do mod, and then you do the number, like let's say 50, and then whatever you want to divide it by. So mod 50 by 5 will be 0 because there's no remainder. But mod 50 by 4 will be 2 because there's 2 left over after you divide it. So this is kind of helpful on some problems. I've never personally used it, but if you get like a really niche problem, you could use this if you want. It's applicable in unit circle as well, because sometimes in unit circle you have a question where it's like 478 pi over 4 or something, and you have to go around and around and around like with 2 pi, and modulus is very helpful here. So that's about it. Now, keyboard shortcuts in general, cube root, it's just CBRT, like that. It'll give you a 3 in the root there. Now, next one is going to be square root, SQRT. This just gives you a root, pretty self-explanatory. By the way, all these functions are down here in this tab if you forget any of them. It's just a lot easier to type it. So SQRT will give you square root like that. Next one is going to be nth root, which is very helpful. Nth root is just NTHROOT, and it'll let you type a number inside of the root there. So pretty cool. Once again, NTHROOT. Next one, if you want to type an exponent, let's say you have like 10 to the 5th power, you just use shift and then whatever your caret symbol is. So usually 6, shift 6, and you can type an exponent here. Also with the exponents, if you have multiple numbers in the exponent, you have to use parentheses, because if you want to do like 10 to the x plus 1 power, you can't just do this because it'll like put the 1 down here. That's bad. So you want to do 10 parentheses x plus 1, and now it'll actually show the numbers inside of the top exponent. So parentheses on that always, it's better for organization anyway. Next one is division. If you have like a really big equation, I don't know, something like this, and you want to divide it by a number, you just highlight the whole thing and click the slash button, and then you can divide the thing. So this is pretty cool. Keep that in mind. Next one, distance and midpoint. Let's say I want to find the distance between like 1 comma 1 and 2 comma 5. All you do is do distance, parentheses, and then each of the points separated by a comma like this. So like first one, 1 comma 1, second one is 2 comma 5. And now it'll find the distance between these 2 points. So that's pretty cool. Also midpoint, will show you the point in the middle. It's in the name. Midpoints, and there you go. It actually graphs it too. That's pretty cool. I don't usually use this, but there might be a question where it's applicable. Next one is percentages. Usually percentages, you're going to use a tilde or a list of some sort, which I will explain more in depth. But for example, let's say you wanted to find like A is, let's say the question said A is 50% of 100. Well, then you just do A tilde 50% of 100, and it'll solve for A for you. So pretty cool, change it to anything. Now, the caveat here is if it says like percent more or less on a problem, you have to convert it to percentage of using a specific procedure that I will explain later. You basically add 100% if you have more, and then vice versa for less. But anyway, we'll get there later. Next one is just like functions in general. Let's say you have f of x equals like 10x plus 1,000, and you want to find f of 100. Well, this would be kind of weird to do by hand, so you can literally just type in f of 100. Now, the caveat here is you have to have the equation defined as f, because if I have like g of x equals 10x plus 1,000, and then I put f of 100, Desmos has no idea what f is. So you have to do g of 100 to match it. So this thing, like g, f, etc., is just a naming thing. G of x versus f of x does not change the actual value of the equation. It just is like a different name. So you need to match the name essentially and just do that. That's pretty cool. You could also do like f of 10 plus f of 3 over f of 1,000. It's really helpful. You can do a ton of stuff like this. You can do multiple functions. Like let's say you had g of x equals 5x plus 30. And it's like, okay, hey, Scott, find f of 30 divided by g of 2. Well, literally just type in it. F of 30 divided by g of 2. And it gives you 32.5. I don't even know what that is. You have to solve it by hand. Pretty tedious. But it literally tells you the answer is 32.5. So nice. Now, next one is sine and cosine. There's a question on the March SAT where this will be very helpful. But if you have like sine of 50 and you want to find that value, this is going to be a wrong value because by default, Desmos is in radians. So you have to go to the wrench symbol here and change it to degrees. Perfect. And now this is actually the correct value. Now, this is applicable especially on the problems where it tells you like cosine of x plus sine of y equals 90. Because if this thing is true, or sorry, hold on. Angle x plus angle y is 90. So therefore, if they add up to 90, they are like complementary to each other. So therefore, cosine of x would equal sine of y. I'll show you this in practice. So let's say you have like sine of 10 and then cosine of 80. Cosine of 80. There we go. These are equal because they add up to 90. So this is a specific identity you need to know, and this is pretty helpful, or this is pretty applicable to this thing I'm teaching right now. But make sure you switch to degrees if you're evaluating degrees. Lastly is constraints. So let's say you have like x squared, and you just want to evaluate it from like 0 onwards. You would just say like x is bigger than or equal to 0, like that. And then it just shows you the graph fulfilling this constraint. So this is pretty helpful sometimes. It's not really that, like, it's not, you don't need it. It just makes it a lot easier. So I have never really used this personally just because I prefer simplicity over everything. I've scored 800 math multiple times, but it does help if you just want to see it visually. So I do recommend it if you want to see it. Anyway, I mean, that's pretty much all Desmos can do. We're going to go more over in depth, by the way. If you keep, or if you forget any of the stuff I told you, just go to this bottom tab here. It shows all the stuff. You have like absolute value, all the functions here, statistics, whatever. And remember, you can always type in sine and cosine. And yeah, that's pretty much it. There's some other like stuff where you can change the colors of the graph and stuff, but it's just kind of like not that helpful. So I felt like I didn't really need to include it. And yeah, that's pretty much the beauty of Desmos. You can do so much stuff here. And let me know if you guys have any questions because there's a lot of info here. But let's go and move on to the rest of the course. Starting off with the basis of everything on Desmos, we have one variable equations. What is a one variable equation? Well, it's kind of in the name. It's just an equation with one variable. So for example, 5x plus 100 equals 5,000. This just has x in it. This can be like C or B or G or something, but it's just one variable, like one constant that you don't know. So that's one variable equation. Usually it's x. Now, with these equations, you are always going to plug them into Desmos. They're pretty easy to do by hand, but even I just use Desmos. It's way easier, right? So you want to plug the equation into Desmos, and then the vertical lines will be the solutions to your equation. So here, if you plug this thing in, it tells you that your solution is 980. Let's do an easier one. Let's say like 5x plus 1 equals 6. Well, x is just 1. You probably do that in your head. But it tells you visually here the solution is the vertical bar. Now, it's not always going to be a solution where it's a vertical bar. If you have like a system, they might intersect. But if you have a one variable equation like this, it will be a vertical bar, okay? That's a big differentiator I need you to understand, okay? Vertical lines are solutions when you have one variable equations. Now, here's a little note. You can replace the constant with x. Let's say this equation was like 5c plus 1 equals 6. As you may notice, it's not going to graph because c is not a graphable term. We have to switch out c for x. So I actually do this a lot. If you have a variable on the test, you can just switch it out for x, as long as you keep it constant throughout the whole equation. So here we only have c. So I can just put x inside, and there we go. We graphed it. So that's about it. That's all you have to know for the one variable equations. Let's do a couple examples just to make sure we have this. First one, 5x plus 10 equals 50. What is the solution? If I saw this on the test, I'm immediately going to graph it. So just type it in. 5x plus 10 equals 50. And then it'll just tell you the answer is 8. That's it. It's just the answer is 8. So you type in 8, get the answer. It's like a 3-second problem. Easy peasy. Now let's do something a little bit harder. So this one, if 4x plus 5 equals 17, what's the value of 8x minus 3? Start by graphing the second or the first thing. And it tells you the solution is going to be 3 here. So therefore, that means x is 3. Now, the mistake everyone makes here is they graph this equation and then they like see where it intersects or something. But this is not correct because once you solve for x, this value of x is like constant in the whole equation. So you need to apply it to this new equation. So basically, now that I know that x is 3, I'm just going to take this equation, 8x minus 3, and sub in 3 for x. So it's going to be 8 times 3 minus 3. So the answer of 8x minus 3 is going to be 21 because we solve for x and then we plug it into the new equation. That's pretty much it. So this is like a 4 out of 10 question. Now let's do something a little bit harder. It says, what value of p is a solution of the equation above? So we have p, and p, right? Just one variable. I'm going to switch out all of them for x because I want to graph it, right? So 3x plus 2 plus 4x minus 5 equals 2x. And now it'll solve for x. In this case, it's p, but it doesn't matter. It's still a variable. So it solves for this unknown variable. The answer is going to be 2.8. So you put 2.8, And the fraction I think here is going to be 14 over 5, which you could do as well. Yeah, that's it. That's your answer. So switch out the variable for x if you deem it necessary. Usually it is. And yeah, let's do a harder one now. It says, one solution to the given equation can be written as 3 plus root k, where k is a constant. What is the value of k? Well, let's try and graph this thing first. We have x squared. As you notice, by the way, it's only x's, so it's a one variable equation. So x squared minus 6x minus 7 equals 0. Now, let me rewind. If you just graph without the 0, it'll show you your quadratic. But if you set it equal to 0, it'll now show your solutions as vertical lines. So these are the same thing. They're both your solutions, except when you set equal to 0, it'll show you visually as a vertical bar, right? So same thing. Solution will be -1 and 7. And it says one of these solutions can be written as 3 plus root k. So 3 plus root k. And then you can add a slider here. So just to reiterate what I said in the first video, a slider just assigns a variable to this constant. So I'm going to add a slider. By the way, it's not always going to be a blue box, okay? Sometimes it will be just manually typing. So I'm going to type in k equals 1 on a new line. I think it's good practice to just type it in because you're not always going to get the blue box. Anyway, we have this slider now, and we want this number, 3 plus root k, so 4 in this case, to be equal to one of our solutions. So we want it to be equal to 7 or -1. So let me just drag it until that happens. Okay, 6, too small. Let me increase the balance to like 20. Drag it up here. Once again, I want it to be 7. Oh, there we go. So when k is 16, this solution is equal to 7, so therefore your answer is 16. Now you might be wondering, Scott, why did you choose 7 and not -1? Well, because you can never get -1. If you are adding a root to 3, you're never going to get -1 because the k value can't be negative. You can't root a negative number. So it's never going to be a negative value, which means it just has to be the positive one you're using. I think a good rule of thumb is just like to drag it until you fulfill one, and then you know that's the answer. You could also do like this, x equals 3 plus root k, and then you could just drag it until it lines up with the green one, right? Which makes it a little bit easier visually. It's the same process, So anyway, that wraps up one variable equations, and I'm not going to sugarcoat it, honestly. If you don't understand one variable equations and you don't get good at it, you're kind of screwed. Because this is like the basis of all of algebra. If you can't do this, you can't do systems, you can't do two variable equations, you can't do equivalent expressions, you can't do a lot of stuff, okay? So this is extremely, extremely important. If you do not understand it, please send me a DM or mention me in the Discord, ask me to help. I will help you out. It's extremely crucial to your knowledge on the SAT. Let's go ahead and move on. Next one is systems of equations. Now, these are just as easy as single variable equations. You should never, ever, ever get these wrong. These are the freest points of all time, as I have written here. Number one is plug it in and look at the intersection point. A lot of people get confused between this and single variable equations. The difference is single variable equations give you a vertical bar as a solution, whereas a system will give you the solution as an intersection point. So wherever they intersect is a solution, whereas single variable is like a vertical bar. That's the difference. So one, you plug it in. Two, you claim your free 20 points or 10 points, whatever the question's worth. It's really, really easy. It's that simple. So let's do a question. It says, the solution of the given system is x comma y. What's the value of y? Well, let's just plug it in. X plus y is 140. And then x plus y equals 176. Nothing fancy. It intersects here, so the value of y is 36. That's it. It took me 5 seconds. So the value of y is 36. That's your answer. There we go. No effort whatsoever. Next one. The solution to the given system is x, y. What's the value of x plus y? So it's the same thing, except we're going to add them. 4x equals 30 or 20. And then negative 3x plus y equals this. Now the solution is the intersection once again. So the value of x plus y is 5 plus 8, which is 13. There we go. It's really that easy. Now, let's do one that's maybe slightly harder. It says, the solution to the given system is x comma y. What's the value of x times y? Okay, we're ramping it up a little bit here. But you just literally type it in. So it says, okay, that's my line. That's my second line. They intersect here, where x is 0.6 and y is 3. So it's literally just that times each other, and you get 1.8. So once again, just literally a 10-second question, you get the answer. That's it. Let's move on. This one says, the solution to the given system is x comma y. What is the value of 17 over 2x plus 18y? So it's the same thing. We're just literally going to plug it in. We have 1/2 x plus 6y equals 25. Then you have 5 over 2x plus 6y equals 23. So we're going to get two intersections, or one intersection, I should say. And then this is -1, and this is y. So a couple ways we could do it, but let's just do this. 17 over 2x, let's add a subscript or something. Or let's just do like a and b, just to add like sliders, plus 18b. And then we're going to say that 18 is, b is 4.25 because that's our y value. And then a is -1 because that's our x value. So the answer of this thing right here is 68. That's it. Now you could also just do this. Let me rewind here. X, y, replace y manually with, what is it again? It is 4.25. So let's do this. And then x is -1. So let's do this. And then you get 68. So same exact process. You're just plugging it in, finding the intersection point, and then doing whatever they say. So this is about as far as systems go. Sometimes you will have to add a slider or do something more complex, but we will get there later. This is exactly how you solve systems. Once again, if you don't understand this, you are genuinely cooked. So I want you to fully understand this topic in depth and the last one before you move on to anything else. Okay, now we have amount of solutions, and this is also extremely important and pretty easy as well, but there are a few nuances I want to make sure you guys understand. So first of all, the amount of solutions is the amount of times that your system or your equation intersects one another. If they intersect once, that's one solution. If they intersect twice, that's two solutions. If they are parallel, that means they have no solutions. And if they are infinite, that means they're literally the same line. So for example, let's say we had like 2x plus 5 and 2x plus 5. Well, as you can see, these two lines are just completely overlapping each other. So therefore, they are infinite, okay? So infinite literally means same slope, same y-intercept, same exact line. Now parallel is a little bit different. Your y-intercept is different, but your slope is the same. So this is what a parallel line looks like. And you always want to make sure you zoom in to make sure that's actually parallel and drag and like go all the way over here. And as you can tell, like these are just going to be parallel regardless. So that's pretty much all you have to know. Just make sure you graph the lines separately because, for example, let's say you had like 2x plus 3 and then you had this equal to like 2x plus 3. Well, this is not going to show any lines, even though you know this is clearly infinite. So you have to like take this and put it on a separate line, and now it's going to show you the lines, and clearly this is infinite because they go over one another. So the lesson learned is if you have infinite solutions, it's not going to graph it if you set them equal. However, no solutions does the same thing. So for example, let's say you had like x equals x plus 10. These are no solutions because no matter what value of x is, they're not going to have a solution. And if I type them in, it's not going to show anything. So you have to like show this on a separate line, and now they're parallel, so therefore you know there are no solutions. But this is a trap because no solutions shows up as the same as infinite. That's like really bad because some people will type in the equation and then get it wrong because they mistakenly look at an infinite solutions graph and say that it's no solutions or vice versa. So you want to make sure you graph the lines separately. It's very, very important. And also, a little trick here, sliders are extremely important. So make sure you are very familiar with sliders because usually you're going to have to add a slider for like some variable. For example, right here, I'm going to spoil it, but we're going to use a slider there. Anyway, let's do some examples. It says, how many distinct real solutions are there to the given equation? This is pretty much as easy as it gets. You're just going to drag the thing. We're going to graph the thing. And then see how many solutions there are. So we have one. Yeah, that's it. It's just one. So when you set it equal to 0 or set it equal to something, it'll show you these solutions as a vertical bar, like I said in the earlier video, okay? Therefore, there's one solution to this equation. That is it. Now, you might have an equation where maybe you have this graph, and then you have another line like x plus 10, and you want to look for the solutions in this one. Well, it's going to be how many times it intersects. It's going to be 2, clearly. 1 here, and then 2 there. So it's a little bit different if you set equal to an equation or equal to 0, whatever, because it'll show the solution as a vertical bar. So a little bit different, something to watch out for. Now, let's move on to the second one. It says, in the given equation, b is a constant. If the equation has a no solution, what is the value of b? So like I said before, if the equation has no solution, they are not going to intersect. They're going to be parallel. And or like if you graph it normally, it'll just show it as a vertical bar, but it won't show anything. Okay, so let's just graph it. And like I said, with amount of solutions, we just want to graph them separately. So let's do b minus 5 times x, and let's do y equals 12. So both of these are equal to y because they're both equations, right? So let's add a slider. And then it says the equation has no solution. What is the value of b? So you literally just drag it until there is no solution. So in this case, kind of a weird one, but this is no solution because they never intersect. Whereas with any other value, if we set it like here, there's going to be an intersection point. But when b is 5, there's nothing. They're parallel, even though it looks kind of weird. They're like horizontal. But they're parallel, therefore, by definition, they are no solution because they never intersect. So the answer is 5. This is pretty much the same process for all of the no solution problems. Now, infinite's going to be a little bit different because you're going to drag it until they like intersect, like overlap fully. But yeah, anyway, let's do the next one. It says, in the given system, A is constant, A here. It has infinitely many solutions. What's the value of A? So remember what I said before, where if we have two lines, in infinitely many solution system will be two lines that overlap each other fully, right? So we want to graph this thing, and then 12x plus 20y equals A. And then we add a slider, and we just want to graph it and drag the slider until there are infinite solutions. So like here, we're literally just going to drag it until it overlaps. So when I go down, it goes further away. That's bad. I want to go further up. Let me increase the bounds to like 50. It's probably going to be kind of big. Over here. Okay, I went past it. Let me zoom in to make sure I have this accurate. Okay, it is 44. Let me make sure it's good. Yes, it is 44 because they fully overlap. No math needed. Literally just dragging a slider. So this is, I mean, pretty much the same procedure for all the different types of infinite no solution questions. Now, let's do a pretty hard one. This is about as hard as it'll get. I guess there's a couple more that are hard, but this one says, in the equation above, A and B are constants. If the equation has infinitely many solutions, what are the values of A and B? And thankfully, they give us some options here. So here's what I'm going to do. I'm going to take both the equations. This one has two constants. That's not good. And then this one has nothing. It's just a normal line, right? And it gives you options for A and B. So once again, you want to get into a like procedure of just predicting what you're going to do before you just start plugging stuff in blindly, because that's how you get Desmos problems wrong. You want to predict exactly what to do and how to do it before you even start typing stuff in. So I see this. I see, okay, I have options for A and B. So I just want to like plug the options in for A and B and see if it's infinite, because our condition here is that they have to be infinite. So you need the lines to overlap fully, right? So what I'm going to do here is I'm going to add a slider for both of these and just go one by one the options. A is 3, B is 2. Are these infinite? No, they're parallel. Next one, A is 3, B is 6. Let me see here. These look pretty infinite to me because they're fully overlapping. So the answer is B immediately. You just put the answer, get it right. But you can check the other stuff as well. So no, that's one solution. There's one as well. So the answer is going to be B. Why? Because they fully overlap each other. Therefore, it is infinite. So let's go back to the takeaway here. Parallel, no solutions. It will not show any lines if you graph it like as the vertical bars. But you want to graph them separately so you avoid that, because if you graph it like equal to 0 or equal to something, it will graph the parallel and the infinite lines as the same thing. Like it'll show no solutions for both of them. So that's not good. You want to graph your equations separately and see if it literally like visually intersects. So that is the takeaway here. Graph them separately, please. And sliders are so crucial on number of solutions questions. And yeah, that's pretty much it. Also, a lot of people ask me, like, why do you not put y equals? It's the same thing. It's the same exact thing. It's just literally like naming the equation, sort of. It's like saying that this is the name of this one is y, this is y. It still graphs it. Desmos recognizes it as an equation. You don't necessarily have to do this. And also, y is the same as f of x if you come into that at some point. Except f of x is better because you can use that as a function. You can do like f of something or whatever. Here you can't do it because I have like two of them. But you get the gist. So regardless, it doesn't really matter if you put y equals. You can just graph it normally. But I guess it's good practice to do that. So just put y equals this thing, y equals this thing. And then in your head, you're thinking like, okay, they're equations. So it's probably a little bit better for your mental procedure. But anyway, this lesson is very important. So I really hope you understand the last three because they're like the fundamental of all of Desmos. And also, a solution is a vertical bar intersecting the x-axis. However, like let's say for example, a lot of people get this wrong. 5x plus 10, and then you have like negative 2x plus 7. the only solution is where the two lines intersect, not all the gray dots, because the gray dots show you the intercepts. It shows the x-intercept and the y-intercept and the solution. So a lot of people will say, oh, this is a solution. It's not a solution. They don't intersect. The solution is where the two lines intersect. So this is an intercept. This is an intercept. Do not mistake the intercept for a solution. They're completely different. Okay. I forgot to mention this in the last video. It's so important. Do not get caught up on doing that mistake, So that's it. Let me know if you have any questions and drop a question in the Discord or the chat if you have any questions. Let's break down how to solve equivalent expressions. Now, equivalent expressions, questions in general, you can always use Desmos for. Yes, always. Every single time you can use it. It's actually pretty crazy. But it's not always going to be the same way. There are basically 3 distinct ways you can solve equivalent expressions questions. Now, first one, which is the easiest, is just going to be graphing and finding the overlapping line. This is like, for example, let's say you have like x squared and then x times x. These are obviously equivalent, but you can look at this and tell that they're equivalent because they overlap like this, you see? So this is the easiest one. You literally just type the options and see which one overlaps. That's graphing. So option 1 of solving is graphing. Now, option 2 is actually going to be substitution. What does this even mean? Well, let me show you an example. Let's say you have x squared, and then, or let's say you have a squared, and then you have like options here. You have a times a, you have a times a squared, and you have like a times a to the 7th power, right? So it's like, okay, let's say it says your given equation is a squared. Which of the following is equivalent to this equation? Now, obviously, you could just solve this in your head pretty easily. However, if you look here, you can just add a slider for a and see which one gives you the same exact value as the given equation. So let's say a is 100, and then this is 10,000, and this is 10,000, so they're equal. This one is a different number, so that's wrong, and this one is way too big. So all you're doing is you're adding a slider, and you're plugging in some random number. Do not pick 1 or 0, by the way. Do not do it. Pick 100 or something, and see which option is the same number, because if it's the same number, no matter what value of a you set, then it has to be equivalent. That's just how it works, right? So this is substitution. This is very good. Sometimes you might have to add multiple sliders. It might get a little bit finicky there, but it's the same process regardless of which option you pick, like if you had a slider or whatever. So that is the second one, which is substitution. Substitution, let me write that down. Now, lastly, is actually going to be regression. Now, we're not going to cover this yet because it is more advanced. I want to make sure you know the previous stuff first, the more basic stuff. But regression, we're going to go over on like in 1 or 2 days. Okay, so regression is the third way. It's actually very, very good. We will get there soon. But we're focusing on graphing and substitution first. These are much more important and much more prevalent. Okay, now, in general, equivalent expressions, you want to find the overlapping equation. I already went over that. X cubed and then x times x times x. It's the same line because they overlap. So that's it. Now, if you have an equation and you have like an x, it'll graph the line. But if you add a y, it will not graph. So what you have to do is you have to finish the equation like this. It is not going to graph if you have a y in it. You have to finish the equation. You don't need anything else if you just have an x because the equation is completed. But if you have a y, it's not going to graph. So keep this in mind. You have to finish the equation. Now, third is always verify your answer. A lot of these questions are very easy. You can do this in your head in like 5 seconds if you're like very mentally like you're a good mental math person, right? But I do not recommend it. I can do all these questions, every single one in my head, but I don't because it's really easy to mess up. I'm a human, right? I make mistakes. So I would prefer to do Desmos and then solve it in my head or do it on paper or vice versa. You want to use multiple methods to check your answer. So always, always spend the extra 20 seconds to verify your answer. It is always worth it every time. You have plenty of time. You should not be optimizing for speed. You should be optimizing for accuracy. You need to get the question right, not save 15 seconds, right? So always verify your answer in 2 ways. Now, lastly, substitution method if you have a lot of constants. For example, if you have like, I don't know, A, B, and C, then you might use sliders because you're probably not going to use X and Y because you have 3 constants. So you're probably going to do some sort of substitution or like sliders or something, okay? General rule of thumb. For example, let's say you have a question and it says, let's say you have A, B, C, and then you're like, okay, which option is equivalent? And then you have like, I don't know, A times B times C or something. Obviously, these are the same, but just to verify, let's say we had sliders for all of them, and we say A is 10, and B is 19, and C is 100. These are the same, so therefore they are equivalent. This is how you would approach the more complex equivalent expressions questions. So that's what I would recommend. Anyway, let's do some examples now. So first one, very easy. It says, which of the following is equivalent to the given expression? All you want to do is just type in the thing, right? 2x minus 7 plus 4x plus 5. And then you want to see which line overlaps it. That's it. So 6x minus 12, is that the same? No, that's parallel. That's wrong. 6x minus 2, that overlaps it. Let me make sure. You always want to make sure you zoom in. And this overlaps, definitely. So the answer is just B. That's it. You just want to see which one overlaps. This is the first method. It's a lot simpler than the other methods, but it's only going to be usable on like the easy medium stuff. Now, moving on, it says, if x is not equal to 0, which of the following expressions is equivalent to this expression, right? So all you want to do here is just type the thing in. Type it in. Square root of 25x to the 6th, y to the 4th, and then on the bottom is x to the 4th. And then this is not going to graph. So I'm going to predict here, I'm probably going to set this equal to like 100 and to see which graph overlaps this one. It's a very weird graph, but the process is the exact same. We're just going to graph the options. So we have 5x squared, y squared equals 100. Is that overlapping? No, definitely not. It's not even close. So it's not A. Now let's try B here. We have 5y squared over x. Okay. Let's see. What's overlapping here? Let me keep it, right? Sometimes the graphs are a little bit, finicky and weird. So let's keep B. And then C, you have 25y squared over x, right? So this is definitely not going to be correct, not even close. Now D is 5xy squared. Is this going to be correct? It is not going to be correct. So the answer is going to be B. Now, why is it like kind of glitching a little bit? Well, sometimes if you have like really big numbers, it'll glitch. So we can just like lower the values. And then as you can see, it clearly overlaps. And yeah, that's about it. You just want to see which one is equivalent. And also the algebraic reason why this is not graphing like fully is because you 5y squared over x. So this thing is not going to be like, it's not going to have the negative parabola. So you're just going to look at the graph that overlaps. This is the basic one. You have x and y. You want to set equal to a number. That is it. The answer would just be B. None of the other ones are even close. So sometimes you will run into a question where like it doesn't graph the whole thing, but it overlaps like 90% of it, right? So it's the only thing that matters. Yeah, okay. Let's move on. Now, the next one, it says, which expression is equivalent to this thing or B is bigger than 0? Okay, well, this is substitution because we just have one variable. And we could do substitution or we could do graphing. What we could do here is we could just replace the B with x, do x to the 7 over 10, and then just graph the options. So like A is going to be 10th root, B to the 7th, and then we just replace B with x. Is this the same? It is. So the answer is immediately just A. But you could also do substitution to verify. So B, and then we have B here, and then you just add a slider. Let's say like B is 100. It's the exact same thing. So that's the only one that could be possibly correct because we add a slider for B and make it really big, and they're the same. So the answer is immediately just going to be A. That is pretty much it. Cool. Moving on. Okay, now the last one, I have a ton of constants here. It says x squared equals n plus n and y squared equals n plus p, which of the following is equivalent to this expression. And then you have like 4 options, and it's n, p, and m as well. So you have 3 variables. This is a lot to take in. Now I'm immediately thinking sliders. It says which of the following is equivalent to x squared minus y squared, and it tells us like what x is and what y is as well, right? So let's just type in the expression. We have x squared minus y squared squared, all squared. And it tells you x squared equals n plus n. So let's do this. Let's just replace these. Instead of x squared, I'm going to put in n plus n. And then instead of y squared, I'm going to put in n plus p. Because it tells me that they're both equivalent to like what they tell me, right? So if x squared equals n plus n, I put that in here because it goes here. And then if y squared equals n plus p, I just put it in here for y squared, right? So then you square the whole thing because it tells you it has to be, just add sliders for all of them. Let's say m is 10 and n is 1000 and p is like 67.45. Doesn't even matter. You pick some random number. Now you just graph all the options and see which one is going to be the same number. That's it. N squared minus 2np plus 2np plus p squared. Is this the same number? It is. So the answer is immediately A, but let me double check to make sure I didn't mess something up. Plus 2np plus p squared. Is this the same? No, not even close. Not B. And then C is this, 2np plus p squared. Is this the same? Not even close. And then D is m squared minus 2mp plus p squared. And then no, this is not even close either. So immediately, the answer is just n squared minus 2np plus p squared, which is just a. So once again, this is substitution. Why did I do it? Well, I have 3 sliders, n, m, and p. That's a lot of stuff. So I'm probably thinking substitution. You can also graph this technically as well. You could kind of just replace all the variables, but I prefer to do substitution here. I find it to be way easier. Once again, it does not matter what numbers you pick because it's going to be the same regardless. If they're equivalent, it doesn't matter what you sub out, what you sub in. So that is it. That's equivalent expressions. You have one graphing, replace with x and graph it, and make sure that if you have y, you finish the equation. Always verify your answer. It's extremely important. It's easy to mess it up. You do not want to make silly mistakes because if you make a silly mistake, it'll take away like 20 points or 30 points. That'll like screw you up really badly. That will tank your score. So pacing is less important on math than reading because you should not be taking 5 minutes for a problem anyway, right? So take the extra 20 seconds, verify your answer, get the question right, claim your free points. It's that easy. And then substitution when you have a lot of constants. That is it. A lot of the time you can use multiple methods, by the way, and then we're going to get into regression in a little bit, but that is the gist of equivalent expressions. Now let's do the quiz. Next, we have functions, and functions questions, Desmos is going to do all the work for you. I mean, like literally all of it. So the only thing you need to make sure you do is make sure you define it correctly. Now, what I mean by this is, for example, let's say like you have f of x equals 5x plus 10. It's now going to recognize that f of x equals this equation. So if you do like f of 10 on a new line, it's taking 10 and it's putting it for this function right here. So it's basically recognizing, okay, f of x equals this thing, so then I can do whatever I want with like f of whatever. So like let's say f of 10 minus f of 2 all divided by f of 1000 or something, I don't know. You could do this function because it literally knows exactly what numbers to put and where to put it because like they're putting 10 here, they're putting 2 here, they're putting 1000 there, and they're doing all the math, right? So you need to make sure you define it properly. If you define this as g of x, now it has no idea what f of 10 is because you don't have f. It's basically like a name. Like g of x versus f of x doesn't change anything except for the fact that it changes the name. It doesn't change the function itself. It just changes the name of it. So if you had like h of x, you would have to do like h of 10, h of 2, h of 1000, and now it'll do the work. You can do whatever procedure you want here, like h of 10 times h of 2 times h of 7 and then divided by h of 1 or something, and then it just tells you what it is. So it does all the work for you. You just have to make sure you actually name the function properly. And also transformations, like if you put h of x minus 3, it's just going to shift it down by 3. And it's really cool because you don't even have to know that minus 3 is a transformation down because it literally just does it for you. Additionally, like if you did h of x minus 3 inside the parentheses, it'll shift it to the right by 3. This is something I see people mess up all the time. They like flip it back and forth. So you can literally just type it in and see if it goes left or right. Like h of x plus 3 will go to the left because it's flipped inside the parentheses. But this is really cool. It'll do all the points, all the math, all the transformations for you. Here's a big issue I see with a lot of people when they first learn this. They will just like type the tilde in for all these equations. You never want to do this. You want to actually define your equation with an equal sign. If you have a tilde, you're estimating something. You do not want to estimate here. You want to define h of x as this equation. So that's why we're using an equal sign and not a tilde. So make sure you do not spam the tilde once you learn it. That's like a big issue. As soon as I teach people regression, they're like, oh my God, that's insane. Just start spamming it and everything. You don't want to do that, okay? You need to use it wisely. We will get to regression in a bit. Anyway, let's do some examples. First one says, the function g is defined by this equation. What's the value of g of 20? Well, like I said, you just literally want to type in the equation. 9 over 20x plus 41, and then just type in g of 20. So the answer is going to be 50. That's it. Like literally 3-second problem. Just make sure you define the problem correctly, because if you do like g of x or you do like h of x, now it has no idea what g of 20 is, right? So make sure you name it properly. It's just a name. H of x, g of x doesn't matter. It just changes like what the actual point is going inside of. Now, next one, it says the function h is defined by this equation. For the function h defined above, what's the value of this thing right here? H of 14 minus h of 4, and we're given h of x, right? So it's literally to say h of x equals x plus 11. Get rid of the subscript, it's an accident. Over 5, and then just do h of 14 minus h of 4. So therefore the answer is just 2. That's it. No logic needed whatsoever. You just literally type the equation in and then type in whatever they ask you for on the next line. Here's an actual like hard one. It says h of x equals absolute value of b over b minus 9, where b is less than 0. This is a condition here. Whenever you see a condition, you have to fulfill it. If it says like b is less than 0 and you put b is 30, you get it wrong, right? You do not want to do that. I've seen many people get this question wrong just because they define b as like a positive number. It has to be negative. So let's define h of x first. Absolute value is going to be right here. Absolute value of b over b minus 9. And then b is less than 0, right? So let's say b is like negative 100. It doesn't matter what number you specifically pick as long as you fulfill the condition. So next line, we just do h of 12b times h of 5b, and the answer is 100. That is it. And it doesn't matter what number you pick, just to show you, as long as you fulfill the condition. If you made it like positive, now it's 64. That's bad. We're not fulfilling the condition anymore, so you have to just fulfill that. That is it. So honestly, pretty easy stuff. You just have to define the equation properly, and Desmos is going to do all the work for you. This work for transformations, points, math, all that stuff. Don't spam the tilde. Just use the equal sign. This is like as basic as it gets. So you do not want to be spamming the tilde on the really basic problems. Just graph it, let it do the work. That's about it. Here's how to solve inequalities in Desmos every single time. Now, these are less frequent than all the other stuff we've done so far. This is about 1 to 2% of the test, whereas the other stuff was like 6%, but it still shows up. And you should do it in Desmos every single time because it's really easy. Now, let's just go over real quick. So the shaded region will be your solution. What that means is this. Let's say we had like y is greater than or equal to 5, and then you had like, I don't know, x is greater than 10 or something. The double shaded region will be your solution. So any point inside of this area right here will be a solution. Now, let's say we just had 1. It would just be anything inside of the shaded region. But if you have multiple lines, you have to have like the double shaded region. So like, once again, if you had something like this, the solutions will not be here or here. It has to be inside of the double shaded region. So that's about it. Now, the difference between greater than or equal to and just greater than is, let me show you how it'll actually look in the graph. If you have y is greater than or equal to 5, the solutions will include the solid line. So for example, if you had like 18 comma 5, this would be a solution because it rests on the solid line. But if this were to be a dashed line, then this point would not count because it's on the dashed line. It's not inside of the solution. So that is the difference. I see people that just like look at the point and see it's on the line and then they say it's the solution. But if it's on the dashed line, it doesn't count, right? It has to be inside of the field. Whereas like if you have something like this, then it actually counts because it's on the shaded region. Because greater than or equal to includes the equal to, which is the line. Now, that's about it. Always use Desmos and make sure to zoom in. I see a lot of people who just like look at the question. Maybe, let's say you have something like this. And you're like zoomed out here. Let's say you have 18 and then, I don't know, 4.75. And if you're zoomed out, that looks like it's in the line, honestly. It looks like on the line pretty easily. But if you zoom in, it's not on it anymore. So you should not like get the question wrong based off of a stupid mistake like this, okay? Just don't. Make sure you zoom in, verify your answer, double check it, because it would be a complete travesty if you were to get a question like this wrong. That's about it. Let's move on. This one says the shaded region represents the solutions to an inequality. Which ordered pair is a solution to the inequality? So once again, the point has to be inside of this region. Let's see. First point, negative 4 comma 3. So this would be like, that's not even close. It's like over here. So that's wrong. Now you can graph this visually or just look at it on your paper. Or I guess not on your paper, on your laptop. So look at this. This is at -1, -2, which is going to be right here. If we zoom in, it's going to be this point right here. That is not inside of the region. So that's wrong as well. Let's try C. C would be 3 comma 5, which looks like this. If you look in the actual field, 3 comma 5 is going to be right here. That is inside. So the answer is C immediately. Now let's check D just to make sure we're not tweaking out here. 0 comma 6 would be right here, and that is clearly not inside of the region. So therefore, the answer is going to be C because it's the only one inside of the region. So just make sure you type all the stuff in and see which one is in the region. It's that easy. Next one. It says, which of the following ordered pairs is a solution to the system above? So once again, you have inequalities here. Let's just graph it, right? And get the answer. So you graph the first thing, x minus y is less than or equal to 0. By the way, little trick here. If you type in like greater than or less than and then equal sign, it will make this. It'll put the little thing under, which means equal to, right? Or you just go to the keyboard and click one of these things here. You can do that as well, but I would prefer to do this. It's a little bit easier. Anyway, we want to find the solution. So once again, we just want to see the point that lies inside of this little double shaded field here, right? 2 comma 1, that's not inside, definitely, not even close. That's wrong. 3 comma 0, that's also wrong. 1 comma 1. Ooh, that is quite close here. Okay. So it might be this because we have double shaded or we have solid lines. Let's check D first. And this one is outside. So this one's a little bit weird, but the answer is going to be C. Why? Because the dot is inside of the region, technically, because it's on the solid line, right? So if you zoom in all the way, it's on the solid line here. So therefore, the answer is going to be C. And if you need to, you can verify it algebraically, but I never ever need to do that really because Desmos is the king here essentially. Let's move on. This one says, which of the following consists of all the y coordinates of all the points that satisfy the system of the inequalities above? Okay, so we'll just graph the thing first. That is your rule of thumb. And then let's look at the inequality here. Okay, all the points are going to be in this double shaded region, and you want to find the y value that fulfills this, right? So let's see what this point is. The y value is 7. So therefore, all of the shaded region points will have a y value that's above 7, right? Because this is like the lowest it goes. Any point above that will be a solution. So the y value must be above 7. Like the y value cannot be, for example, like the point cannot be 5,7 because this is outside of the region. So the y value must be above 7 to be a solution. Now, A is technically correct, but you need all of the points, right? So it's just B because any value above y or above 7 is a valid y value. For example, let's say you had like, I don't even know if this is a solution. It's like 5, 12, 13, 14. There we go. So like you see how the y value is clearly above this. It has to be because it's not a single point where the y value is below that and it's a solution. So the y value must be above 7 to be a solution. That's about it. Now, like I said before, this is all going to be Desmos here. Does all the work. I never really do use my hand anymore unless it's like a word problem. You will get word problems that are inequalities, but that's kind of a different method that I will teach you in a little bit. Inequalities are all Desmos. Make sure you zoom in, verify your answer. Do not get the question wrong because you're trying to speed run the test. Speed running is bad. Verify your answers, get the question right. That's it. For circles in general, I would prefer that you memorize the standard form of a circle. Thankfully, it's not that hard to remember. It's just x minus h squared. I have it written right here. And then plus, this is on the outside, by the way, x minus h squared plus y minus k squared. And then equals r squared. R being the radius, right? So let's say, for example, your center is h comma k, right? Your center here is h comma k. So the x value of the center is your h value. So for example, if your center is, I don't know, 5 comma 10, then your equation will look like this: x minus 5 squared, and then your y value is your k value. So your 10 just goes here because that goes with y, right? So x minus 5 squared plus y minus k is 10, and squared. And then equals r squared. So let's say the radius was like 10, for example, then r squared would be 10 squared or 100. So this would be your equation if, hypothetically, your center was 5 comma 10 and your radius was 10. Okay, so you're literally just typing this, or you're getting the center and you're putting it in for this equation. Once again, your x value is your h, your y value is your k. Do not flip the numbers. If it's a positive 5, this will be minus 5. So like accordingly, let's say, for example, you want it to go up by 5 units, then you're really going to subtract, because if we're shifting 5 to like up by 5, that'd be 10. Now it's going to be minus 10. So you're not actually adding 10 to this equation, you're going to subtract it. It's like flipped. Because remember back to translations, if you have like f of x and you're trying to go to the right by 5, you'd actually subtract 5. Here it's kind of a similar thing. If we're going up by 5, we're going to subtract 5. Same thing with y. So x is left to right, y is up and down, and then r is just a radius here. Now, if we have a circle equation, for example, let's say we have x minus 5 squared plus, I don't know, y minus 10 squared equals 76. And we want to find the diameter, or sorry, we want to find the distance between the endpoints, which is the diameter, right? So all you do is find the distance between these 2 points. And I recommend you use the up and down values. So you just find the distance between these. So you just like add these as a point and just label it. Like, let's say, I don't know, this is B and this is C. And then just do the distance function I said before. Or just do distance between A and B. So just do, I don't know, B comma C, whatever. And then it finds the distance, therefore this is the diameter. Now the radius would be half of this. So you just take this and you divide it by 2. So this would be the radius of the circle. You find the distance between the endpoints and then divide that by 2, because the diameter is double the radius. So find the diameter, divide that by 2 to find the radius. That's about it. So next, make sure you're looking at the endpoint and not the intercepts. This is a big mistake I see a lot. Let's say you like x plus 1 squared plus y minus 2 squared equals 10. And you're trying to find the diameter here, or the radius, whatever. A lot of people will mistakenly look at the wrong point. Let's say this is like little bit closer. This is really hard to tell which is the endpoint because you have like a gray dot here and a gray dot here, right? But if you look closer, this is actually the intercept. That is not the endpoint. This is the endpoint right here. So the higher y value, or like the lower one in this case, I guess, would be your endpoint. So just do not pick the intercept. Make sure to zoom in, because if you were to get the question wrong based off of looking at the wrong point, that would be absolutely catastrophic. So do not let that happen to you. Zoom in, make sure you verify it is not an intercept, it's an endpoint. And like I said, you can use the distance function or midpoint if needed. Let's say, for example, you wanted to find the center of the circle. All you do is take this point right here, and then this point right here. Make sure it's the endpoint. Take my own advice. And then let's just say this was like A, this is like B, and then just do midpoint between them. This would be the center, because the center is in the middle of the circle, right? It's between the two endpoints. So just do this. The midpoint is going to be negative 0.2, comma 2. That is the midpoint, or the center. So that is pretty much it. Make sure you memorize this standard form. It's extremely helpful. Now let's do a couple questions. So let's delete this. First one. The graph of the equation above is a circle. What's the length of the radius? If you memorize the standard form, you can literally just tell that the last thing is r squared. So if r squared is 100, then r is root 100. So 10. So the radius would be 10. That's it. You could also graph this and then find the distance between the endpoints and then just divide by 2. But it's not really necessary if you have the circle memorized. You can only do r squared if this is in standard form. For example, let me skip forward. This, I actually don't have an example. It's right here. Never mind. This is not standard form. So you cannot just do root 8 here. That would not work. It has to be in standard form. That's important. Yeah, okay, so that is pretty much it. Just root this thing if it's in standard form. You could also graph it if you need, but I don't recommend it. Next one. A circle in the xy plane has this equation. Which of the following gives the center of the circle and its radius? Well, keep in mind, x minus k plus y minus h, or sorry, x minus h, y minus k. I flipped it. So in this case, our center is going to be negative 9, because we're flipping it, and then positive 4. So the center is this, negative 9, positive 4. So immediately this is gone, and this is gone as well. Now the last number, this is in standard form, so the last number is r squared. If r squared equals 2401, then r, which is the radius, would just be root of 2401, which is going to be 49. So the radius is 49, meaning the answer is going to be D. So that is it. If you have the standard form memorized, it's very easy. Literally just flip the x value, flip the y value. That's your center. And then root the last number, because that's your radius. Nice. Next one. This is pretty hard, actually. Circle A in the xy plane has this equation. Circle B has the same center as circle A. And the radius of circle B is 3 times the radius of circle A. The equation of finding circle B is this, where k is a constant. What's the value of k? So we have this standard form, and it says it has the same center as circle A. Okay, pretty cool. Or circle B has the same center. And the radius of B is 3 times the radius of A. What is the radius of A? Well, the last number, keep in mind, is r squared. If r squared equals 25, then radius is root 25, which is just 5. So the radius here is 25. Or sorry, it's 5. Radius of first thing is 5. Okay, first circle radius is 5. Keep that in your mind. Now, if the radius of circle B is 3 times the radius of A, it would be 3 times 5, so just 15. So the radius of this circle is 15. The mistake everyone makes here is they will say the answer is 15. Yes, the radius is 15, but k is not 15, because keep in mind, back to the standard form, the last number is r squared. So if we know that r is 15, then we have to square that to find the k value, because that's the last number in the equation, right? So we have to square 15, and then it just ends up being 25, or 225. 225, the answer is 225. That is it. So if you have the standard form memorized, this should be no problem whatsoever. Just make sure you actually find the true constant and not just the radius, because that's only like step 2. Okay, next one. It says the graph of the equation above is a circle. What is the length of the radius? Now we can't just root this, like I said before, because this is not in standard form. So we are going to have to graph it. Because the normal way you'd solve this is completing the square, which I will never, ever, ever do on the SAT. It's way too long and tedious. I would just rather use Desmos because it's way easier, right? So we just want to find the distance between these two endpoints. So which is 5, 3, and these, right? Let's just say A is this, and then B is this. And we want to find the length of the radius. So all we're going to do is do distance between A and B. and this is the diameter. So we have to divide that by 2 to find the radius, which is just 7. So the answer to this one is 7. Let me recap. We graph the thing. We want to find the radius, right? So we want to find the diameter, which is the distance between the two endpoints. I prefer to use the vertical endpoints, like up and bottom. You can use left and right if you want to. You can just like drag till it snaps on, but it doesn't really matter. I just prefer to do this because it shows you like the top and the bottom of the gray points. Anyway, after you determine you have the endpoints, you just find the distance to find the diameter and then divide it by 2 because the radius is half of the diameter. And that is it. If you have the standard form of a circle memorized, you should have no problem whatsoever. And if it is not, for whatever reason, if it's not in standard form, you can just graph it and find the answer. So that's about it. Okay, this is regression part 1. I'm going to chop this up into 2 videos because regression is very complex. Okay. This video is going to be just the basic regression, so like the tables and stuff like that. Now, all you have to know is if you're given a ton of points, you should use a table to find the slope or the equation or whatever you're looking for. So for example, let's say our question says like we need to find the slope of the linear function which passes through 2, 5 and 3, 10. Well, you should just type in table and then type in these points and then you can find the equation. So you graph it, click this little button up here, by the way, add regression, click that, and now it'll graph it. And what it does is it shows you a line between the points and also gives you the equation. Now, if perhaps you had a quadratic or an exponential, you can change this dropdown to fit those formats. So for example, let's say you had a different question. Find the slope of the quadratic function, which passes through, 2, 5, 3, 10, and 1, 10. But it didn't ask for slope. Let's say it asked for like, find the x equals 5 value of this function, right? So all you do is plot these points. It tells you it's quadratic. So you just want to put the points in, change this thing to a quadratic, and then find the value when x is 5. So you type in x equals 5, look at the value, and do this. So the answer would just be 50 here. What you could also do is just take this equation and just put it on a separate line and just change it out for f of x, and then just say like f of 5, and it tells you the answer is 50. You can do that. That's fine. It doesn't really matter. Now, the gist is, if you have a quadratic, an exponential, a linear, sometimes cubic and quartic, but not really, it's usually just those 3, you just type the points in and change it to that format to get the answer to whatever you're looking for. Now, the issue is this is very limited. Like, if you look here, the linear regression will only give you the value of mx plus b because that's a line. And the quadratic will just give you ax squared plus bx plus c in this structure because this is a standard form of a quadratic. And then an exponential will just give you a times b to the x power because that's like the standard exponential function format, right? So it's just going to give you the standard formats and you can't change it at all. So in case you're curious, these are the formulas for whatever, like linear, quadratic, and exponential. I was covering them up on my face cam. But this is the only structure that the like basic regression will output. You can't change it. So this is where step 2 comes in, okay? Let's go back to this part. Use the drop down to fit the correct equation, but like I said, this is limited. You can't change anything by yourself. So if you need to match a specific equation, just use custom regression. What is custom regression? Well, custom regression allows you to change the format of the equation that you're looking for, right? So let's say, for example, back to this, it gives you a quadratic, and then it says the format of this equation is like, 5 over b squared, and then plus 5x plus c. It says, okay, hey, this is the format of the equation. Well, what you do is click this little button, regression, export it, and then just change it to that format. So you would just put like 5 over b here, and then this is squared. So you take away the x because you want to match the format, and then you put 5 here, and then it would just solve for b and c for you. Now, this is a terrible example, but all you do is you just change the regression to fit the format of what you're looking for. So let's do an example to really model what this looks like. Also, you don't have to click this little button right here. You just type in y1 tilde to the equation, right? So basically what this does is it gives you the y1 values in the table, and then you relate it to the equation. So like, for example, bx1 squared minus 20x1 plus 25. What this is going to do is it's going to solve for all the constants that you need using these points. And once again, you have x1s here and you have y1s. And this is using the values in the table, because if you look here, the x values are x1 and the y values are y1. So it's using all these values and it's basically simulating an equation to solve for all the things you need. And it's using all these points in the table. Now, a big issue I see is sometimes people will accidentally put like x2 or something. Well, x2 is a completely different number than the table. The table is x1, so you need to match that table to use the points properly. Anyway, let's do an example. This one says the function h is defined by this weird equation where k, m, and n are constants. In the xy plane, the graph of h of x passes through these 2 points. What is the value of h of 0 plus h of 8? Okay, well, we are given this format of the equation, and we're given 2 points. So if we're given points, we should use a table. Okay, table 340, and then 8, 960. And then keep in mind, the format of this equation is this right here. So here's what I'm going to do, right? I'm going to say y1 tilde to all of these things. Let's say like k, x1 minus 4 squared minus m. By the way, make sure you exactly match the structure, because if not, you will be completely cooked. Anyway, square this, minus n, perfect. All right, so we have it in, and it passes through these 2 points. So here's what it's doing, just to make sure we understand. It's taking these x values, it's taking these y values, and it's basically saying, okay, hey Desmos, this is the equation that this table is representing. It's using all these points inside of this regression, and therefore it solves for k, n, and m. So now what we can do is we can solve for h of 0 and h of 8. Now, since we're Desmos gods, we're Desmos pros, we just want to duplicate this regression and then change it to h of x, so we can use this h of 0, h of 8. If you watch the functions video, you know what I'm talking about. We just want to graph this equation and then type in h of 0 plus h of 8. It'll do all the math for us. So we just solved for k, m, and n, and I just want to duplicate this regression here. So let's click the little settings button and then copy it. And then I just want to switch it to h of x. So h of x equals this. Just change it to the normal stuff. And then remove all the subscripts because we solved for all the letters. Perfect. And then now that we have the equation graphed, we can just solve for these 2 numbers. So just do h of 0 plus h of 8. And it just does all the math for us. So the answer is just immediately 1920. Now, just to recap, we put the points into a table because we're given a bunch of points. We change it to the equation given. And then we literally just find k, m, and n, or Desmos does all the work for us. Then we copy the equation, change it to h of x because I want to plug these points in for h, the function h, and then it solves for us. Now, the reason why we have to do this part here is because if we have y1, we can't do like h of 0 because it doesn't know what h is. If we didn't have that, it's just not going to solve anything because it doesn't know what h is. You have to define it as h of x to actually recognize what h of x is, and now it can do the math for us. So this is how custom regression works. Because, as you can tell, this equation is very complex. It is not the given equation in the like normal regression of the table. So let me move my face cam here so you guys can see it. And yeah, that's it. We just use a table. We change it to that format. We copy the thing. We type in h of 0 plus h of 8. We get the answer. That's it. So this is a very standard custom regression question, and I would use custom regression a lot. It's very good. It's very flexible. It's very versatile. You can do a lot with it, like a lot. And yeah. Also, please keep in mind, you might notice I have y1 here. I'm doing y1 because it has to relate to this table, and you would not use an equal sign because the tilde is estimating all these constants. So do not put an equal sign because it won't do anything. You have to put a tilde so that it actually recognizes, okay, hey, I need to solve for k, m, and n. Otherwise, it won't solve for that because, once again, the tilde is used for estimation. The equal sign is used to graph the actual thing. Here, I have an equal sign because I want to graph it. Whereas with a tilde, I'm just estimating the constants. So that is the whole use of the tilde. So do not use the equal sign if you're trying to estimate constants. That's the whole use of doing the tilde in the first place. Okay, let's do another one just to make sure we have this down. This one, we're given a function that says h of x equals c times d to the x over 4 power. And then we're given 2 points here. Now, this is a note I wrote over here where sometimes it'll say like this line passes through a point, or it'll say literally f of 1 equals 9. What this means is the x value is 1 and the y value is 9. So this is literally the same exact thing. Do not get confused. This is the same exact thing. They're both the same point. They're both 1, 9 because the x value goes inside of the function and the y value is here. So they're the same exact thing. You type it in the same way. Do not confuse them. Now, anyway, back to this question. It says, in the given function, h of 8 is 20 and h of 12 is 320. What's the value of h of 16? So we have 2 points here. We should use the table immediately. So 8, comma 20, and then 12, comma 320. Okay. Now, what's the value of h of 16? So I have this structure of the equation, and I have the points into a table. So once again, I want to change h of x to y1 so that I can like match the table and use the points, right? So y1 tilde to cd to the x over 4 power. Perfect. What's the value of h of 16? Well, I don't know yet, but I do know that I have c and d. So what I'm going to do is, same as last problem, I just want to find the h of x equation, and we just solve for c and d. So let me just duplicate this and then change it to h of x equals cd to the x over 4 power, and then change the x back to normal. Perfect. So now I can just do h of 16, and I'm just going to solve for it. Just 5, 120. Why? Why is it 5, 120? Well, once again, we just use a table. We change it to the format of what they give us, and then we know what c and d are. So now we just type in like literally this point and just solves for us because it knows what c and d are. So now I have it defined as a function. Go back and watch my function video if you haven't. We have it defined as a function. We just type in the point. We type in 16 for x. It tells us it's 5120. Does all the work for us. So this would be like literally a 20-second question, whereas most people would solve it in like 5 minutes. I'm telling you, like custom regression is actually nuts. You need to master this concept before we do the more like crazy Desmos stuff. But this is pretty crazy by itself. Now, once again, just make sure you are using the squiggly line, the tilde, whatever. And you have to use that, not the equal sign, because we're estimating C and D, right? If we're estimating something, we have to use a tilde. Make sure you use that. We copy it, change to h of x so that we put the point in, and then just solve for it. Now, these are some specific equations you should probably remember if you're trying to use custom regression. There's 4, and they're all pretty easy to remember. So first of all, we have a circle equation. I already went over this in a previous video, I think the one before this, but it's just h minus k squared plus y minus, it's h minus, x minus h, y minus k squared equals r squared. Sorry, I just confused myself there. So the h comma k is your center, where the h value is your x value of the center, and your k value is the y value of your center. So like, for example, let's say your center was like 3 comma 5. Your equation would be 3 here and then 5 here. And keep in mind, this is like flipped. This is positive 3, whereas this is subtracting 3, right? You're just putting it in. Don't like, mess anything up. Just put the number inside. That's it. Now, r is your radius. So for example, let's say the radius was like 5. Radius is 5. Then this last number is just 5 squared. So 5 squared is 25. That's it. So this is what your circle would look like if your center was 3 comma 5 and your radius was 5. That's about it. So just remember this equation. You should have it remembered if you watched the last video. But you will very rarely use custom regression on circles. I've never seen it on the SAT personally, but in theory, it could show up. Yeah. Exponentials, you should use this format where you have a times b to the x power minus c. Minus c is like controlling up and down, and then this is the base here, and this is the coefficient. So the base is like the thing with the exponent on it, which like controls the kind of increase or decrease of it, and then a is a coefficient of it. So this is what you should remember if you want to change it to an exponential. Let's say you're given a table or points, and it's like, this is exponential, find C or something, or find B. Then you would just type this format in and then solve for whatever you need. So use that. Once again, you just need like y1 tilde, this thing right here. Just change this to subscript. And yeah, that's about it. Now, next one is vertex form of a quadratic. This one's kind of hard to remember, but this is it. Let's say your vertex is, I don't know, 2 comma 5. Your format is this: a times x minus h squared plus k, where once again h comma k is not your center, but rather your vertex in the scenario. So you put 2 here, and then the y value of k here, and then a, whatever it tells you a is. Sometimes you'll have to like add a slider and just drag it, but it depends on the problem. This is a vertex form. So let's say, for example, you're given like a vertex of a parabola, and you're given one other thing. You would have to put it into vertex form, because with a quadratic, you need 3 points to be able to graph it properly. But a lot of problems will just give you the vertex and then one other point. If you have that, you have to put it into vertex form to graph it properly. Like, for example, let's say you have let me do this problem exactly. It says maximum height of 288 4 seconds after. So that's 4 comma 288. And then it says it hit the ground 10 seconds after, so 10 comma 0. And then it's not going to graph properly, as you may notice here. If you put a quadratic here, the vertex is supposed to be at 4,288. But if you look here, the vertex is incorrect. It's in the wrong spot because it's supposed to be in the top, the tippity top or the very bottom, because that's the max and the min. That's the vertex. And if we look here, this is not on the vertex, so that's incorrect. Therefore, what we need to do here is change it to vertex form. So what you could do is just export or type whatever you want to do and change it to vertex form, which once again is going to be a times x1 minus our vertex is going to be 4 squared plus 288. So now with this new vertex or this new quadratic, it's actually going to have the correct vertex in the right spot. So therefore, it graphs it properly, and then you can analyze it. So a big mistake I see is using the wrong graph. Like the vertex must be at the top or the bottom, not on like a side here. So it has to be in vertex form. You can only graph it in the standard form if you have like 3 points. Yeah, that's about it. So anyway, back to the equations. You have to have circle memorized, exponential, vertex form, and then slope-intercept form. This is the easiest one by far. Obviously, like most of you will have this remembered, mx plus b, where m is a slope, b is a y-intercept. There are a specific type of problems on this like type of question where you have to know slope-intercept form because you have to like change f of x to that. We're going to do an example later. But just make sure you know what slope-intercept form is because it's actually pretty useful on custom regression. Anyway, let's go back to this question and actually solve it in depth so I can actually explain the process, because this question is extremely common. I've seen it many, many times, like a lot. I've taken the SAT probably 7 times at this point, 6, I guess, and I've seen it on half of them, which is a very high frequency. Anyway, a quadratic function models a ball's height in feet above the ground in terms of the time in seconds after it's launched. So the ball was launched from an initial height of h feet above the ground, so that's like the y-intercept, and reached a maximum height of 288 feet above 4 seconds after it was launched. So x is your seconds because that's like your input. Let me do thicker marker. X is seconds, and then h is your feet. So that's like your y value, right? So x is your seconds, your input, and then feet is your output, your y value. So x is seconds, y is going to be feet. This is extremely important. Now, it tells you that the maximum height is 288 4 seconds after. So that's 1 point. And since it's a maximum, this is a vertex. So I know this is a vertex. Cool. 1 point. Now, the ball hit the ground 10 seconds after being launched. So when x is 10, it hits the ground. What does hitting the ground mean? Well, that means you're 0 feet above the ground because you go up, hit the ground, right? So that is 0 height, which means your point is actually going to be 10, 0. So we have 2 points here, not 3. So I'm going to plug this into a table. And as I showed you before, it is not going to graph it properly even when I change it to quadratic because the vertex is in the wrong spot. This is very, very bad. So what I need to do is, because I'm given the vertex, I want to change this to a vertex form. So a times x1 minus 4 squared plus 288, because this is vertex form once again. Get rid of this purple thing. I don't want it anymore. Now it says, what was the initial height from which the ball was launched? Initial height is your y-intercept. That's where you start, right? So basically, like you're here, you shoot up, and then you come down and hit the ground. So the initial height is where you started, which is the y-intercept, because that's x equals 0. So if we look here, we just look at the y-intercept, which ends up being 160. So the answer here is simply 160. And I got this just from knowing vertex form, because I'm given the vertex, I'm given one other point, which happens to be the x-intercept, and you just type the vertex into vertex form and find the y-intercept. That's it. So keep in mind, you need to know vertex form if you have like vertex form in one other point, or sorry, if you have a vertex in one other point. So yeah, just make sure you have this memorized. It's pretty easy to remember. Just a times x minus h squared plus k. Yeah, and just make sure you have these 4 things memorized, because I would much rather you have these memorized. You could, in theory, get these questions right without knowing it, but it's just way harder that way. So I would rather you just put a little bit of work in and memorize the equations. Anyway, let's do some more examples here. This is a question I see a lot of people struggle on, actually. I've seen this like question asked to me a lot. So let me frame my cam here down. All right. It says the function g is defined by this equation, where a is a constant, and it passes through this point and this point. It contains the points. If g of t is 0, what is the greatest possible value of t? Okay. So we have 2 points here. Let's start by plugging them in immediately. So we have 0, negative 450, root 450. Perfect. And the format of the equation is this right here. So what I want to do is just type the thing in, y1 tilde negative root of x1 squared plus ax1 plus 450. Perfect. And it tells you that a is negative 59. I don't necessarily know if this is even true. It could be inaccurate, but let's see. We're given 50 here. Let me see if I can verify this is correct. If you take a look at the r squared value, it's right here. R squared is 1. That is a really good sign. You will not be using this that much, but when r squared equals 1, that means your regression is accurate. That's the accuracy of your regression. The lower it is, the worse it is. So if it's 1, that means our regression is accurate here. And a is an integer, which is always reassuring. So therefore, a equals negative 59 for sure. We know that. We just determined it. But we're looking for the greatest possible value of t. Now it says g of t equals 0. That means the y value is 0, so y equals 0. And you might notice here you have 2 points. You have 9 and 50. So the greatest possible value of t, which is the x value, is 50 because it's a higher number. They're both equal to y equals 0, but the bigger one is 50. That is it. So once again, all we did here is we just took the points, we plugged them into a table, changed it to this regression here, and then just interpreted the points to see which one is the greatest possible value. Now, what I want to show you is a question exactly like this, where the regression actually does not end up being accurate. And you have to do an extra little step to make sure it's accurate. Let me show you that real quick. Okay, now we have a question exactly like the one we just did, except we might run into an issue. Wink, wink. Okay, so we want to put these points into a table as usual. 2, 0, and then we have 0, negative root 358. Perfect. And then what we want to do is analyze, okay, we have this equation. So I'm going to say y1 tilde negative root x1 squared plus bx1 plus c. And then it says if h of m equals 0, what's the greatest possible value of m? So you could look here and say, oh, it's just 65.2. The issue is your r squared value is like 0.68. So this actually is not going to be accurate. And you can double check this by looking here. This line is not going through your 2 points. That is a very, very bad sign. You want your line to go through your points given, or else it's probably just going to be inaccurate, which is definitely not good. So here's what we want to do. This is like a little hack that you can do to make sure your regression is true. I don't really know why it even happens, but I've just found it through experimenting. If you do this, it just makes it accurate. So r squared is 1 now, and then c is just like 358. So it's like basically an integer, which is always reassuring. So you just add like a really tiny value, and now it's actually accurate because it's going through the points. And if we're looking for the greatest possible value of m, we're just looking for the bigger x value when y is 0. So it's just going to be over here, which ends up being 179. If you zoom in all the way, you should always zoom in, but it's just 179. This is really weird, but here's another way you can do it if you think this is way too niche for you, which honestly it kind of is. You can find c really easily because it says when x is 0, y is going to be negative root 358. So here's what you could do. You could say, okay, you have this equation, x squared plus bx plus c, and it's saying that when x is 0, y is negative root 358, right? So that means if x is 0, this is going away because you're putting 0 in. This is going away because you're putting 0 in. So you just have negative root c, and it's telling you that this is equivalent to negative root of 358. So if that's true, then c is literally just 358. So from this logic of using this point, you could just say, oh, well, c is 358, and then it just solves for everything. And it's r squared is 1. That's perfect. It's going through your points. It gives you the point exactly, which is amazing, and it's going through both of your points. That is great. So I literally just use a point to my advantage. I put 0 in for x, and then I solve for y. And from that, I just knew that c is 358 by using a regression. So this is a really, really reliable way you can solve for really weird problems like this. So use the points to your advantage. Points are your best friend on the SAT, I'm telling you. I don't want to say every problem, but half of the problems you can just use the points to your advantage. When you're given points at least, you can use the points to your advantage every single time. It's the whole point. So just use them to your advantage. And if you have any questions about this custom regression thing, shoot me a DM on Instagram. But let's do one more here that I made, actually. I made this question. You've probably seen it before. So it says the table gives 2 values of x and corresponding values of g of x, where g of x equals f of x plus 3 over x plus 4, and f is a linear function. What is the y-coordinate of the y-intercept of f of x in the xy plane? So we have this table here. So we should plug in a table. Whenever you're given a table, just put it in. I'm telling you, every time. Put it in, and then it tells you that this function g of x, keep in mind this table is g of x, equals f of x plus 3 over x plus 4. And f is a linear function. So I want to type this format in for this table. So as usual, y1 tilde f of x plus 3 over x plus 4. Now here's a massive mistake I see everyone make when they do regression. They just type in x1 for f of x1. This is completely incorrect. One, our r squared value is like completely inaccurate. But second, this is basically registering x, or it's registering f as like a random constant, which is bad because f is a linear function. It's its own function. So as a general rule of thumb, when you are learning regression, never ever do f of x1. This is a very like niche advanced strategy that you should not use until like your 1500 level, I'm telling you. I will teach you this specifically, but if you're learning regression at first, never ever do this. Like as soon as you use it, you're cooked. You're screwed. So never do this. Anyway, we need to change f of x to something else because right now it's not working for us. If you take the subscript away, it's not going to graph it. That's bad. It does tell us though that f is a linear function. So I mentioned before that you need to know slope-intercept form of a line. If f is a linear function, then a linear function is slope-intercept form. So we can just change f of x to mx plus b. What is this going to do? Well, this is going to graph it now. And this is always reassuring that you have r squared equaling 1. But second, m and b are both integers. And we're looking for the y-intercept of f of x. This is very convenient because b is just your y-intercept of your slope-intercept form, right? So if b is your y-intercept of a line, then f of x, the y-intercept is just negative 25. So the answer is negative 25. That's it. So once again, it's a very normal custom regression question. Type in the table, change to the format, and then all you do is just sub out f of x for mx plus b because it tells you it's linear. And that's like the only thing I could ever think of doing with f of x because you can't just leave it by itself. It's not going to graph. But additionally, like you can't just put in x1 for x because that's not how it works. You can't just shove a subscript in for x every single time. So anyway, I would recommend you make sure you memorize these equations like slope-intercept form, exponential, quadratic, all that stuff. It's very, very important. Now let's go over some like big tips I need to tell you that a lot of people mess up when they're first learning regression. First, using regression on everything. Yes, it's extremely, extremely useful. Like it's like, you know, best things in sliced bread, I guess you could say. It's really, really good, but you should not be using it on everything. Graphing should be your default response to a question. You should be using graphing 4 times as much as regression. You should be graphing, looking at intercepts, maximums, minimums, functions, stuff like that. Don't just spam the tilde on everything. Like I see at first people just seeing like f of x equals 5 plus 3 plus x equals 10 or something. And then they're just like putting a tilde everywhere. Like, dude, it's not meant for spamming. You need to know exactly what to do. You need to go into a problem and predict what you're going to do before you do it. So don't just go in and start willy-nilly spamming tildes everywhere. That's really, really bad. Second is defining constants incorrectly. Let me like go back to this custom regression one we did before. If you're solving for a constant, you cannot define it. I see this problem a lot. People will like do this and they'll define b as like 10 or something. So let's say b is 10 on a separate line. And now it'll completely change your equation because if you define b, it's not going to solve for it. It only solves for your unknown constants, right? So if we define b, it's known now. We have it defined, so it's not going to solve for it. And now we're screwed because it's going to have the wrong value for b. As you can tell by this r squared value, it's not accurate. So do not define a number if you're looking for it, right? If you're looking for a, for example, don't define a. Just don't do it. Unless we're doing factoring, but we'll get there in a second. Third is not giving enough info. Desmos is not a super god demigod, bro. Like it's a calculator based on arithmetic. It needs information to solve for questions. Like I can't just do like b plus c equals 100 and expect it to solve for b and c. It's going to give you 2 random values for b and c. It's going to give you the smallest absolute values for both of them. So you need more information to solve for b and c accurately. Put in all of the information they give you. For example, let's say the question tells you like 3 points, 1 point, 2 point, 3 point. You can't just type in 1 or 2. You have to type in all 3 of them. If it gives you information, you have to use it. You can't just type in like as much as you deem necessary. You need to type in all of it. It needs a lot of info to solve for this stuff. And also a little tip is if you have like 3 or 4 constants, you probably need 3 or 4 bits of info. You probably need 3 or 4 points or whatever it is. Like if you have A, B, C, and D in a problem, you probably need like 4 points. That's like a general rule of thumb. This is not always true, but you should probably just keep in mind you might be missing information if you only have like 1 point and you're solving for 5 constants. Anyway, fourth is not understanding how to plug points. Okay, you need to be using points to your advantage properly. Like you need to use it in a table properly. Don't just like spam points everywhere. You need to have a very detailed system of plugging them in. So if you have a custom regression question, just be like, okay, let me think. I need to put these points into a table. I need to change the table to match the format of the regression, and then that's it. So you need to have a very detailed plan of when to use points and not just like waste them, you know? Fifth, I already covered, but just don't use f of x1. If you're starting off, never ever do this, like please. It's the same with g of x1, f of x1, it doesn't matter. There's only one specific really use for this case, maybe two, and I do not want you to learn it yet. I don't want you to. I personally have never ever used f of x1 on the test ever, and I have scored perfect math multiple times, right? So just don't do it. It's not necessary whatsoever. Now, lastly is using 1, 0, or -1 when defining a letter. There are some scenarios where if you type in like a equals 0 for something, it will mess up your regression. Why? Well, because you do not want 0 and 1. Because in some cases, there are multiple regressions that will be true when a constant is 0 or 1. Same thing with 1. Like if you type in a regression, you get 1, 1, 1, 1, 1 for everything. That's really, really bad. You do not want 1s for everything because that is like showing you it's inaccurate. So just don't plug in -1, 0, or 1. As a rule of thumb, I usually, like when I add sliders, I'll say a equals 2 or something. Because then it starts to be like more accurate. And yeah, that's pretty much all it is. So do not fall into these common mistakes of spamming regression and everything. Make sure you have a detailed plan and predict what you're going to do before you do it. And also make sure you remember these equations. And that is it. That's it for the part 1 of regression. And we're going to do a more advanced version in like a day or two on the course. And yeah, that's it. Let me know if you have any questions. Shoot me a DM. And let's move on to the quiz. Okay, now we're going to do the more advanced regression stuff that is not included in the table. And there's a lot more to learn. So let's break it down. Now, starting with the very fundamentals, we have one variable equations. So the difference between an equal sign and a tilde is very, very simple. An equal sign will graph equations. For example, 5x equals 4. It'll graph your solution. A tilde will not graph it. It will estimate constants. So for example, let's bring that equation back again. If I did like 5x tilde 4, it's going to solve for that same solution, but it's not going to graph it. The graph is from here. So if you have an equal sign, that is for graphing. If you have a tilde, you're estimating the constants. Sometimes you might be doing both at once. You might be graphing and using a tilde, but we will get there later. Okay, so they're distinctly different. The tilde is used to estimate constants. The equal sign is used to graph. Now, let me show you how that would work. Let's say we had like 3x plus 5 equals 2x plus 30. You could put an equal sign if there's just one variable because it's just an x value. It'll solve for the x value really easily. But if you had a constant, you'd probably use a tilde. You could also use a tilde here though, because we have one solution. We could just put a tilde in for the equal sign and change the x to constants right here, and then it'll just solve the equation for you. Now the thing is though, Desmos only gives you the smallest value. So if there are multiple solutions and it's asking for like the biggest or like middle one, you're kind of screwed because it's not going to give you all the solutions. So if it asks for multiple solutions, you should use an equal sign. I don't really know what a good example is here, but maybe, yeah, like this. Let's say it asks for like the biggest solution, then you're screwed here because if you do a tilde, it's just going to give you like the smallest possible value, which is 0. So if you're looking for the biggest value, you're cooked because it's not going to give it to you, right? So you would have to graph it. It only makes sense. You put a graph here, that's it. So if you have multiple solutions, if it's talking about how many solutions are there, etc., use graphing. Graphing should be used on more problems than you use a tilde on. That's a big mistake I see with beginners. They spam the tilde, like I said in the previous video. Don't just spam it. You need to actually know what it's doing. So just keep in mind, Desmos solves for one solution, gives you one solution, and gives you the smallest one. So if you have like 5, you can't analyze all of them. So just graph them. So that is it with the one variable equations. And by the way, if you have a equation where it's like, I don't know, a squared equals a plus 2a, well, this is not x, but you can still use a tilde and it'll still solve for it. This is a terrible example, but you get the point, right? You can just replace x with a or a with x. It's the same thing regardless, because if you're doing x1, it's still a constant. It's like the same thing as a pretty much. So just keep in mind, when you have x, it's going to graph it. When you have x1, this is recognizing it as a constant. So now it's going to estimate it. So if you're using a tilde, you have to use subscript on the x's. By the way, if you're wondering how to type it in, it's just click the x button and then literally type in 1. It'll autofill to the bottom. It'll like auto move down. So that's it. I would graph questions with multiple solutions. If there's only one, you can use a tilde. But usually when I'm analyzing amount of solutions, I'm probably going to just graph it, honestly. Now, the list. Let's break down the list here. Let me see if... Here, let me show you an example before we move on to the list. This is a great example. It says the equation above contains a constant k. If the equation has infinitely many solutions, what's the value of k? Well, as I said in the previous video, if equations have infinite solutions, that literally means they are the same. They're equal, right? So if these equations are equal, I can use a tilde here. So we just put a tilde to this equation, and then it'll just say that k is 3. You can do x1 as random 10 if you want, but it's not going to change anything because we don't really need it. Anyway, k is going to be 3, so the answer is 3. That's it. And the only reason why we could do this is because they're infinite solutions. If they had like no solutions, we cannot do it. So yeah, that's about it. Anyway, let's move on to the list here. So the list is a thing I get questions about a lot because it's kind of confusing. But this is how it works. So your setup is like this. On the left side, you have brackets. Right side, you have brackets. The whole point of a list is to take 2 equations or 3, whatever, and put them all on the same line. This will allow them to combine into one equation, and then it can solve for all those constants. So if you have 2 equations and you're trying to solve for something, you should use a list. And you put the left sides in the left bracket, you put the right sides in the right bracket. So for example, let's say the question told you, I don't know, A equals 20, and B is C plus 10 or something. This doesn't even make sense, but this is how you do it, right? A on the left, right side 20, you got to match it. And then over here, you'd be B, you separate it with the comma. Separate each element with a comma. And then B is equivalent to C plus 10, so you just do like parentheses like that. And then they're equal. So make sure they're in corresponding order. A has to correspond to 20, so they both have to be the first element. And then B has to correspond to C plus 10, so that's the second element. Make sure you put it in order, and make sure you put a comma in between the letters. One of the biggest mistakes I see is putting commas in the wrong place or just forgetting parentheses. Because if you forget parentheses, that can totally throw off the equation. So do not forget those. It's very important. Yeah, anyway. Also, make sure you meet all the conditions. Like if it tells you, I don't know, B is 20 or something, make sure you define B as 20. So it just has to know that information. Anyway, it's an example here. It says m plus n squared equals 74 and mn equals 15. So I'm seeing 2 equations. I have 2 constants. I'm probably going to have to estimate the constants, obviously, here. So I'm going to think a list here because we have 2 equations and we want to relate them all in the same line to solve for m and n. So here's how we're going to set it up. We want to type them both into brackets. Left side, you're going to put the left sides. So we're going to put m plus n squared. And then I'm going to put mn as well. And make sure you put the corresponding numbers because 74 corresponds to m plus n squared. So therefore, I need to put 74 in the first part on the second list. And then I want to put 15 after using a comma. Once again, you separate each term with a comma. So I do m plus n squared according to 74. And then mn is equal to 15. And therefore, I just separate each term with a list, or with a comma, I should say. What is the value of m squared plus n squared? Well, Desmos just solved for m and n, and it's always reassuring that you get a very small RMSE value. You want this to be as close to 0 as possible. If you get like 300, that's really bad, right? So just type in m squared plus n squared, and you get 44. So the answer is 44. That's it. Now, once again, make sure you type in the corresponding spots in the right for the right numbers. So m plus n squared is corresponding to 74. Therefore, they're both on the first element of the list. And you separate the first one from the second one with a comma. And then mn corresponds to 15. So therefore, it solves for m and n. It's basically taking these 2 equations and like basically smushing them together and solving for m and n. If you put them on separate lines, it would not work because it will solve for m and n completely separately. Like it won't think about them as one equation. So make sure you combine them into one thing. Now, next thing is, make sure you meet all conditions. If it told me that m is bigger than 10, for example, then I would have to put that condition. And by the way, if you have a condition, you can use a curly bracket like this. Let me show you. Curly bracket, let's say m was like bigger than 1. Then guess what? It just fulfills a condition, and it basically says, okay, m, you have to be bigger than 1. And yeah, that's it. So if you have a condition, you could put a curly bracket like this, or you could just define it like on a separate line, but this is probably the easiest way to do it. So curly bracket, it's like to the top right of your keyboard. I'm going to talk more about this later, but yeah. Okay. Next one, I have another example here. This one is pretty hard, okay? I want you to see if you can try and solve this by yourself. College Board added this in like the August batch, so definitely a question that could show up on the fall SATs. But it says in the given system, k is a constant. In the xy plane, the graphs intersect at this point right here, where p is a constant. What's the value of k? Okay, so, well, let's look at this point here. The y value of it is 10. So that's pretty important. But we have a system here. So I'm going to plug these both into a list, right? Because my whole goal here is to estimate for k. And we have two equations, so I'm going to use a list. That's that easy, right? So minus x, make sure you change to a subscript. Same thing with y. And this is corresponding to negative 170. Perfect. That's the first equation. Now we put a comma. Make sure you put the comma in the right spot. And then 3x1 minus ky1. There we go. And the next one corresponds to 70 here. So you do comma and then 70. And then you might think the answer is 110 here. It might be, but you haven't fulfilled all the conditions yet. Like I said before, you have to make sure you fulfill all the conditions. If it tells you one thing, you have to make sure you are like adhering to that rule. And in this case, the specific condition is that the y value of the point is 10. So if they intersect, that is a solution. You have this one solution here, and they intersect at this point where y is 10. So therefore, you know, at this solution point, the y value is 10. So therefore, I can just define y1 as 10. And then it'll give me the accurate number. Therefore, k would be 11. That would be it. So you might be wondering, Scott, why didn't you do x1 equals random 10? Well, we don't need to. That's too much information. Desmos already has enough to solve for k. RMSE is 0. That's a good sign. And we know that y is 10, so it has more than enough info to solve for k. And we are good here. We get an integer. It's always a good sign. We got 0 RMSE. That's perfect. So just make sure you are always fulfilling your conditions, because that is the most important thing. You can completely screw up your question if you don't fulfill that. So make sure you do that. And just let me know if you have any questions. Now, equivalent expressions. So equivalent expressions are literally in the name. You have two expressions that are equal. For example, 5x plus 2 equals 3x plus 10. And then you can just use a tilde between these to solve for like x. And a very common question is when you have like a ton of constants over here or something like that, and you have to solve for a, b, and c. So this is where it gets really hard, but you're always going to use regression here. Let me show you. This one says, what's the value of a plus b plus c? And we have two equivalent expressions, two equal equations. Clearly, you have an equal sign, right? So therefore, this thing equals this thing, which means I can just type all these in and add a subscript for all the x's. By the way, you don't have to use a subscript on the constants because it already recognizes it as a constant. The whole point of a subscript is to recognize x and y as a constant, which it usually is not. Okay, so 7 over x1 plus 5 plus 4x1 over x1 minus 4. By the way, make sure to check you typed it in properly, because if you typed it in wrong, you're just going to be cooked immediately. Just double check. Okay, I'm good here. Now, the issue is I typed it in and I got 0, 1, 1, 1, 1. That is always a bad sign. So my issue here is Desmos does not have enough information to solve for a, b, and c. I mean, think about it. Look at the equation. You literally have like a billion constants here. There's no way you could possibly ever solve for this. So what you have to do is say, hey, Desmos, try these values for x. And there are a few ways you could do it, but you could do x1 equals bracket 1, 2, 3, etc. But the issue you'll run into is on a question like this, if you type in a whole number, it will mess it up, because if x was 4 here, you're basically taking these values of x and you're shoving them in for x and like simulating those values. So if x is equal to 4, it would make this equation wrong, because it would be like something over 0, which you can't do. So therefore, that is why the bracket is actually worse than what I do, which is x1 equals random 10. This takes 10 completely random decimals, and it basically just puts it in for like the x values, right? It's saying, hey, Desmos, take these 10 completely random decimal values and just put it in. That's it. And then simulate the values of these letters. Now, I think I meant to put b plus c plus d here, but the answer here would just be type it in on a separate line. So the answer would be 3 here. That would be it. Now, let me just make sure I have it typed in properly, right? Your equation, good is here, good here. And I defined x1 as random 10. Doesn't matter if you do this or like 100 or something, you're still going to get the same answer. It should not change anything. Yes, you might notice a changes, but that doesn't affect our b plus c plus d values. So it doesn't even matter. Basically, just to make sure you guys understand the difference, random 10 is taking 10 random decimals, whereas the brackets are taking whole numbers and putting them in, which is bad because sometimes it can mess it up like this. Now, I'm not going to fault you for doing this because usually this will not happen. It'll be fine. But it's the same thing. If you didn't have this like messing up equation here, then it's going to do the same exact job as random 10. I just do random 10 because I find it to be like easier and more reliable, you know? So might as well do this. The only instance in which I would do brackets over random 10 is if it told me a specific condition. Like if it said, what's the value of b plus c plus d when x1 is greater than 10? Then I'd say, okay, x1 is 11, 12, 13, 14, 15, so on and so forth, right? And the answer is still 3. By the way, this is a rounding error. That's why it says 3.0001. It's just 3. Anyway, this is the same exact thing as random 10, except random 10 just basically ignores the integer values. So that is it. That is how you do these equivalent expression type of questions. You literally just set them equal, define x1 as completely random numbers, and then it'll solve for b, c, and d, or whatever your constants are. Also, before the next question, by the way, I want to explain why we do x1 as random 10. Like, what's the point of that? Well, you're trying to ensure that the constants you're solving for are true at all values of x. So you want to make sure Desmos knows, okay, all these numbers are going to be true at 100 values of x. So therefore, you know they are accurate. That's the whole point of simulating these values of x, because it tests it at this one point, this one point, this one point, and it makes sure that these constants are accurate no matter what. Basically, you're feeding it information to be able to solve for the constants. Okay, now let's move on to a question that's pretty much the same as the last one, except we have an extra condition here, right? So it says the equation right here is equal to this thing, and it's true for all values when x is not equal to 4 over b, where b is a constant. What's the value of b? Okay, well, what we should do is the same thing as last time. Let's just type it in and replace the x values with x1. Okay, then we have bx minus 4 tilde negative 7x1 minus 5 minus 82 over bx1 minus 4. Perfect. X1 is 0. That's very bad. You never want it to be 0. It's always a bad sign. So what we want to do is simulate the values for x to make sure we can solve for b accurately. So same thing as last time. But now we have a condition here. It says x is not equal to 4 over b. The great thing about random 10 is it's taking random decimals. So what are the odds that it gives you the value where x is equal to 4 over b? Probably not going to happen, right? So to say x1 equals random 10. Random 10, and b is negative 5. Now, what is 4 over b? That is negative 0.8. If you look at the decimals, none of these are the same thing. So therefore, you are actively fulfilling your condition by putting random 10 because you're not putting it equal to 4 over b. You can also do like this here where you put a squiggly bracket and you say like, I don't know, x is bigger than 10 or something. And then it's probably going to be true here. But anyway, just make sure you fulfill your condition. Usually random 10 will just fulfill it like automatically without any extra work, and you can just check to make sure you fulfilled it. Anyway, the answer for this one is going to be negative 5 because we literally just type in we're typing a tilde and it solves for it. Make sure you do not forget x1 is random 10. Okay, it's very important. And also, if it like tells you in the problem that x1 equals 0 or some numbers equal 0, it's a very bad sign. If you have like zeros and ones, that's always going to be bad, right? So just make sure if you like finish the equation, you have actual numbers, not just 0 or 1. Yeah, anyway, let's move on here. Next one, we have something very, very similar. It says, for the expression above, let me make sure you guys can see the full question. There we go. M and P and R are all integer constants. By the way, just to refresh, constant just literally means a number with no x value attached to it. Integer means a whole number. So which of the following must be an integer? So it's saying, okay, we have this expression and all these constants are integers. They're all whole numbers. Which of the following also must be an integer? We have these fractions here. So we need to solve for these constants and make sure they are all integers. So here's what we're going to do. We're going to type it in. Px plus r is tilde to cx1 squared plus dx1 plus 48. And you have like 6 ones, right? Yeah, 6 ones. That's really, really bad. So we're going to do the same thing as always. x1 equals random 10. And now they're all integers. So you know that's very good. And also the RMSE value is like basically 0. So now we know we have the accurate numbers, so we can just test to see which ones are integers. 48 over n is 1. That is an integer. 1 is a whole number. How about the second one? Also 1. Last one, 47. Also an integer. So all of these are integers, therefore it would be all 3 of them. I cut off the options, but it would be 1, 2, and 3. So it was like D or something. Anyway, that's all you do. You literally just type in x1 equals random 10. It takes these decimals, it simulates it in for the x values, and it solves for m, n, and p, and r in this case. pretty easily. So pretty cool stuff there. Here you could do the brackets. It wouldn't really matter. It doesn't save you any time. It's the same exact thing. You can also do this dot stuff where you put 1 dot 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 10. It puts all the numbers between 1 and 10. You might be wondering, why did it change the value? Well, it doesn't matter because it's still an integer. Like it didn't change anything regardless. It's just putting different numbers in and solving with different numbers. So, I mean, it's the same thing on this question. Yeah, anyway, let's move on. Got a few more here. So this one says, in the given equation, m is bigger than 1 and r is also bigger than 1. If r equals m to the 4k minus 2, where k is a constant, what's the value of k? We have two conditions here. That's a lot. And we have this right here. What's the value of k? We're going to use a list. We have two equations, right? We're going to have the fifth root of m cubed. And this is equal to r to the 3 over 5. And then r is going to equal, make sure you put the comma in the right spot. It's really easy to mess these up with the exponents. And then also, by the way, exponent, if you have multiple numbers, do parentheses, and then it'll actually do it properly. Now you have ones here, which is bad. It tells you m is bigger than 1 and r is also bigger than 1. So two ways to do this. You can define both of these constraints in squiggly brackets or curly brackets, whatever you want to say. So m is bigger than 1. And then it says r is bigger than 1 as well, right? So they're both fulfilled automatically, but you can also do that if you would like. Doesn't really matter. Either way, the value of k is 0.75. So the answer is just 0.75. Now, an alternate way to do it is, instead of using the curly brackets, you could just define m or r in a separate line. Let me just redo this regression. And then just say like m is equal to 5 or something. And then r, it says r is 5 as well. It automatically solves for it. And then it says k is 0.75. Here's a big issue I see. If you define m and r as different numbers, it's going to give you the wrong value of k. Why? Well, if you look at this expression right here, m and r, you can't define both of them like by yourself. You have to define one or the other, and then it'll solve for the other one. So if you define both of them, that's too much information. Desmos is going to get overwhelmed. That's like inaccurate. So it's going to completely mess it up. Make sure you don't define the numbers that Desmos needs to solve. Anyway, here it doesn't matter what condition or it doesn't matter what method you use to fulfill the condition. Regardless, you're going to get 0.75 as your answer. So on the SAT, you just write it as 0.75. That's it. That would be, or 3 over 4, obviously, but it doesn't really matter. And yeah, that's pretty much it. Moving on, this one says the function g is defined by the equation. If g of b equals negative 15b, where b is a constant, what's the value of b? Okay, well, let's just define g of x first. Like I've said in previous videos, biggest mistake I see is beginners learning like Desmos. They will just type in literally like g of x1 tilde equation. Don't spam it, okay? Like just define the equation and then use the tilde after that. So we have this equation, we have it defined. Now it says g of b equals negative 15b. So g of b equals negative 15b. If we have the regression defined, we can literally just use a tilde with this point. It's just it's not a list, it's just one point to each other. So g of b is going to be equal to negative 15b, and it literally just solves for b for us. Because it knows what g of x is, basically what it's doing is it's plugging b in for the expression, and then saying it's equal to negative 15b. So it's plugging all these values to figure out what value makes this expression true. And the only one that makes it true is negative 0.226. On the SAT, you'd write it as negative 0.2262 technically, because you want to do 5 characters total, not including the negative. And yeah, that's it. So if you have functions, you can literally just type in the naked point, as I say, with a tilde, and it'll solve for all the stuff you need. Because once again, we have g of x defined. If we didn't have this, we're completely cooked, because it doesn't know what g of x is. If you like read this regression, it's going to say b is 1, because that's like what it defaults to. So make sure you define your equation, and then you can actually take advantage of this like function notation stuff. So just make sure you have your expression notated properly, and that's about it. So I'm pretty sure I covered all of it. Make sure when you're estimating constants, use a tilde, and graph the questions with multiple solutions. You can use a tilde if they're infinite, but you can't use it if it's no solutions. You can only use it on the slopes, because if you have no solutions, that means the slopes are the same, but the whole equations are not. Now in the list, make sure you put them in corresponding order. So if one equation corresponds to another one, like once again, let me make sure we have this. Question says A is 10 and B is 20 and C is 30. Well, you're going to do a list, and A is corresponding to 10, and then B is corresponding to 20, right? And then C is corresponding to 30. So you just do it like this. Make sure they're in order because they have to be mapping to the right variables. And then make sure you meet all conditions. If you don't meet all conditions, you run the risk of getting it wrong because of that. That'd be a silly mistake, okay? Make sure you're fulfilling everything. Now, equivalent expressions, make sure all the constants are accurate for all values of x, right? So that's why we're doing x1 is random 10, because we're taking 10 random decimals, putting it in for the equation, and solving for the constants. And then the squiggly brackets are for conditions. For example, let's say like x1 is bigger than 10. And then it'll be like, okay, Desmos, only use the numbers that are bigger than 10. That is all you have to know for regression part 2. Now, common mistakes I see are defining constants you're solving for. This is a big one. Let's say we're solving for a, and then on a separate line, you'd say like a is 10. Well, that defeats the purpose of the whole problem, right? Because you're solving for a. If you say, hey, Desmos, a is 10, it's going to say, okay, a is 10. And then it's not going to give you the right answer. So do not define any constants you're solving for. Unless you're doing like factoring, which you could do, but we'll get there later. Now, list typos are very common. If you're doing like the ABC thing again, and you forget like a comma, then this is not registering it properly. Make sure you're putting the commas in the right spots. Make sure you're mapping it to the right variables. Third is not meeting all conditions. If it tells you b is bigger than 1, and then you put a regression in and b is like 0.2, you're cooked because it's not fulfilling the condition. You know you definitely have it wrong. Now, maybe not definitely. Conditions sometimes do not even matter. You can still get the question right in some cases by not fulfilling the conditions, but I would not risk it. Don't risk it. It's just not worth it. Now, lastly, for getting random 10, like a very easy one to mess up is this one right here. A lot of people type it in, just type in b plus c plus d, but you need to define x1 as random 10 or you're cooked immediately because you need to simulate the values for x to solve for the constants. Yeah, and that's pretty much it. So, I mean, there's nothing much else you need to know. By the way, percentages are a big use case of the list. Like, I don't know. Let me make up an example right now. Let's say the question says a is 30% of b, b is equal to 100, and b is 20% of c. What is the value of, I don't know, c, right? Well, you just type each part in like this. So a is going to be equivalent to 30% of b, right? 30% of b. And then b is going to be equal to 100. And then b is 20% of c. So you type in b again, and then you type in 20% of c. So then therefore, it can solve for c, but you'd have to have one more piece of info. I guess it's probably a bad, yeah, no, this is fine. B is 20% of c, so then it could just solve for c. I put in c here. That's a typo. B is 20% of c, so therefore c is 500, and the answer of c is 500. That's it. So you literally just type in each thing, mapping to each part, and type in, okay, A is 30% of B, B is equal to 100, mapping B to 100, and then I'm also mapping B to 20% of C. A big misconception is you can't put in the same variable twice or 3 times. You can, but they just have to be mapped to different variables, because if you're mapping B to like 50% of C and then 20% of C, that makes no sense. It can only be one at once, right? So you can map it in like to multiple things, but not to the same thing. So if you're defining B multiple times, map it to different variables, and then you're fine. So lists are extremely good for percentages. I use them every single time. Make sure you know how to do this problem. Yeah, that's about it. So we will move on to the other parts of the course. Let me know if you have any questions about regression. And yeah. Okay, now we have expression of terms. Some people call this isolation. You're basically isolating a variable from the equation. Now, what giveaway for this question type is when it says, which of the following gives something in terms of something. In terms of something is your giveaway. So if you're expressing some other thing in terms of some other thing, you can use Desmos, and I use Desmos every time. Even if I know how to do the algebra, I'm always going to do Desmos because 1, it's way easier, 2, it's way faster, and 3, you are less likely to make an error because Desmos doesn't make errors unless you do, right? So that's why Desmos is superior here. But all you do is you basically pick a couple numbers and you use a regression and then find the variable you're supposed to be isolating, and then to see which option equals that variable. And you don't want to pick 1 or 0 when you're just plugging in a couple numbers, right? So let's say, for example, in our problem, we have like A equals B plus C plus D, and then we have to express B in terms of like the other things, right? So algebraically, you would just literally subtract C and D. But what you could do instead is you do this and just say like A is 10, and then, I don't know, C is like 2, and D is like 5. And then that would tell you what B is. So if we want to express B in terms of the other ones, then you just plug in the options and see which one is equivalent to B. That's it. So you just pick random numbers. Doesn't really matter what you pick. Just don't pick 1 or 0, because if you pick 1, there might be multiple options that are correct at the same time. You only want one to be correct. So I usually pick 10 or 5 or something. But regardless, let's do an example. And I want you to try and do it before I do it. So I'll give you a second to pause the video, and let's do it. It says, which of the following expresses M in terms of P and Q? So algebraically, we would solve for M and just isolate it. But we're not going to do that because 1, I'm lazy, and 2, I want to do it way faster, right? So let's just do this. And then it already has values plugged in, but I just like to type in a different value. Let's say M is 100, and then it solves for P and Q. Perfect. So now we know M, P, and Q. Doesn't matter what number you pick. Let me stress this. It does not matter what number you pick for M. Just don't pick 1 or 0. It doesn't matter. It's going to be the same algebra regardless. So now you want to express M in terms of P and Q. So all you do is you type in the options and see which one is equivalent to M. So A, for example, P plus Q over PQ, and you get 0.01. That is not equal to 100. So this is wrong immediately. Let's try B. B is going to be PQ over P plus Q, and the answer is 100. So this value of 100 is equal to M, therefore you know that this equation is equal to M, so the answer is immediately B. And just to show you the other options, PQ times P plus Q, that's way too big. It's not even close. 24PQ times P plus Q, it's going to be way bigger also. So this is nowhere near 100, which is what we're looking for. So the answer is just B here. And like I said before, it doesn't matter what number you pick. Let me show this to you. PQ over P plus Q. And as I drag it, this is going to match M regardless of like what number I have. So it's equivalent. That's it. This is all you do. I do this every single time I see a question like this. It is just so free. It's so free. Next one, pause the video, try and solve this, and let's do it. It says, which of the following expresses T in terms of R and S? So we are isolating T here. So it's the same process. 1 over R plus 1 over S tilde 1 over T. And let's say S is like 100. And sure, these are fine. So which of the following expresses T in terms of R and S? We'll plug in all the options and see which one equals T. T is 1.13 here. So see which one equals this number. R plus S over RS? No, that's wrong. RS over R plus S? That's the same thing. So that's right. And it doesn't matter. As you drag it, it's going to be the same number. So you know the answer B immediately. So you should never, ever be getting expressing T in terms of R and S. Expression of terms, I was trying to say. You should never get this type of problem wrong, ever. It's very, very easy. All you do is use Desmos and plug in numbers. That is it. I don't really think I'll get many questions about this one. It's pretty simple. But if you have a question, shoot me a DM. And yeah, let's move on to the rest. Okay, let's go over some factoring real quick. And there are 3 distinct methods to solving factoring questions. Most of them are going to be graphing. Let me show you what graphing looks like. Let's say, for example, you have x and an x squared. And you want to check if this one is a factor of x squared. The easiest way to check that is if they share an x-intercept, because that means they share a factor, or they share that means this is a factor of the given expression, I should say. Okay, so if they share an x-intercept, therefore they are factors, right? Here, x is obviously a factor of x squared. We all know that, but it's visualized on the graph because they share an x-intercept here. Another example, like, I don't know, x cubed, it still shares an x-intercept because x is still a factor of that. So if it shares an x-intercept, it is going to be a factor of the given equation. This is the easiest one to solve. So let me do an example of this before we do substitution. So it says, which of the following expressions are a factor of this expression, right? So let's go ahead and type this expression in. Minus 11x minus 21. And we have 2 x-intercepts here, so possibly 2 factors. Let's see, x minus 7. Does that share? It does. You should probably zoom in to verify, but yes, that is a factor. Therefore, this one is a factor right here. First one checks. Now, next one is 2x plus 3. This also shares an x-intercept. Let me double check here. Yes, we're good there. So both of them are factors of this expression. Therefore, the answer is D. That is it. It's that simple. Sometimes it'll ask for like a constant, and you have to use a slider to drag it. And sometimes it'll be like an integer, but it's the same thing. All you do is add a slider for that integer, drag it until they share an x-intercept when that thing is an integer. Okay, substitution now. So substitution, all you do is you replace the variables in the equation, and you see if the factor, like that you're evaluating, is actually a factor of the given expression. So if it like divides into an integer or like a perfect square or something, let me show you what that looks like. So this one says, which of the following is a factor of the polynomial above? What you could do is, honestly, I would replace, I guess it doesn't really matter if you replace x or y. Just add subscripts to make them constants. So 30x1 y1 plus 25y1 squared. So I add the subscripts to make these constants so I can do substitution now, because I'm going to like plug in numbers for x and y. Now let's say like this is 10 and this is 4 or something. So you want to plug in all the options and see which one like divides into the given expression and results in an integer, because that's going to be a factor. Or sometimes it'll be a perfect square. It depends on the structure of the equation. But like A, for example, this is 14. Does 2500 go into 14 or other way around I meant? No, it does not. It's a decimal. So it's not A. B, this is 50. So 2500 over 50, that does go into it. And actually, this is a perfect square as well. So I'm thinking it's B right now. Let's try C. 9x1 plus 5y1. 110, does that go in? I'm going to save you the time. No, it does not. So that is a decimal. That's wrong. Now D, 3x1 plus 25y1. This does not go in either. You can test that. So it is not that. Therefore, the answer is going to be B, because if you divide them, you get 50. That's a perfect square. So even better. It doesn't have to be a perfect square. It depends on the structure of the equation. This one is, but sometimes it will not be a perfect square, and it will just be like an integer. So then you'll have to like drag these and make sure that the given expression is factorable by that thing into an integer. So it's not always going to be perfect square, but this one is. All you have to do is check all of them and make sure that they that one of them goes into the given expression and it divides into an integer at all values of like x or y, whatever. So that's about it. That's how you do substitution. Now the tilde is the most advanced one. This is a question that showed up on the June SAT hypothetically. Not exactly like this, but it's very similar. It says that this quadratic has factors of this form, and a, b, c, d, and k are all integers. You have to find the smallest possible value of a, b. So if these are factors of this expression, then that means this thing is equal to this whole expression, because they're all factors of it, right? And it matches the structure of this equation. So it's definitely going to be equal here, which means we're going to use a tilde. And the reason I'm using a tilde here and not the other methods is because we have a ton of constants. It's like really complex. So there's no way we're going to solve this using like x-intercepts or some like rookie stuff, you know? So we want to type it in, and this basically turns into an equivalent expression where this side is equal to this one. So I want to define x1 as random 10. And now I have a bunch of decimals, which is bad. I want to find what k is, because k is the easiest one to factor out. The way to factor out this constant here is to find the greatest common factor of these three numbers. You can do this by hand or in Desmos. Just type in GCF of all of the numbers. So 38, 155, and 77. This finds the GCF, so therefore k is 1, because this is the biggest factor that goes into all the numbers. So therefore k is 1. This is just to make sure. You don't necessarily have to do this, but you should do it in all the problems because it could change your answer. So k is 1. Now I can find a and b. What I'm going to do here is a, b, c, and d are all integers. Right now they're decimals. That's bad. So I'm going to add a slider for a. Let's say it's 1. And just drag a until all 4 of these are integers, because they have to be. Based on this is a condition they give me. We have to fulfill the condition or else we get it wrong. So I have to make sure all 4 are integers. I already know k is an integer, but I have to make sure a, b, c, d are all integers. So I'm going to add a step of 1 to make sure that the slider is accurate. When a is 1, this is still decimal, so this is bad. When a is 2, b is 7, they're all integers. So a, b could be 14. That's a valid answer. Decimal, decimal, these are all decimals. So I don't think I'm ever going to get smaller than 14. And you might be wondering, Scott, why'd you pick A to be a slider? Well, I want to pick one of the numbers or one of the letters that I'm looking for. So I'm looking for AB. So I can either pick A or B, just drag it until I get all integers, and then just find AB. That's it. So pick one of the things you're looking for so you can control that value, and then find AB. So this is the smallest it's going to go. Like A can't be negative here. I guess it technically could, but I think I forgot positive when I wrote this. It's supposed to be positive integers. So the lowest this goes is 14. The answer is 14. That's it. And it still applies if you like added a slider for B. You're still going to get the same value. It doesn't really matter. But yeah, that's about it. So let's say it was a little bit different. Let's say this is on the test, by the way, sort of, where it said this was a factor of this expression, and then you have to find the smallest possible value of AB. Well, it's kind of the same thing, except what we have to do now is this factor is not equal to this side. It's not. The structure is not even close to this side. So I have to match the structure. I have a squared here. I need to add another factor that's also squared to make x to the fourth. So let's just say like dx squared plus z. This is a dummy factor, I call it. Basically, like this is a factor where it factors with this factor here, and it makes it equal to this structure because we have to the fourth power and then squared, like that. And now we still say x1 is random 10. And it's the same process. Say a is 1, a is 2, ab is still 14. It's the same exact thing, except we have to spawn in the factor and make like a dummy factor, as I say, or like a ghost factor, whatever you want to call it. So that is it. We want to make sure it maintains the same structure and then find the smallest possible value of AB. That's it. So this is how you do factoring. Not too bad, honestly. Let me know if you have any questions. Let's move on. Next up, we have slope, parallel, and perpendicular lines. So mainly, this is just going to be logic and also using custom regression and tables. So it's not too bad, but I just want to make sure that we're on the same page here. Whenever the problem gives you 2 points on a linear function, just use a table. Like let's say, I don't know, once again, you're given 2, 5 and like 10, 30. You just graph it, it'll tell you the slope. And then you can figure out everything else. So if you're given 2 points on a line, that's very, very easy. Now, if you have 1 point and a slope, it might be a little bit harder. But what you could do is this. Let's say, for example, you have a question that said, I don't know, like you're given 1 point, 5, 10, and then the slope is 10 or something. Then you would just use a table and then say 5, 10. And then use custom regression where you do y1 tilde, slope is 10, which is your m value of slope-intercept form. By the way, you need to remember mx plus b, right? So y1 tilde, m is the slope, so 10x plus b, and then it'll solve for b for you, so b is negative 40. And then it would probably ask you like, I don't know, like the point goes through 10 comma k, what is k? Then you'd be like, okay, well, x equals 10 with that point, and then just look where they intersect, and the value of k is just 60. So this is how you do it. If you have 1 point in a slope, you just use custom regression and plug the slope in for m. That would be it. Next, parallel is same slope. We just went over this, but you have to know this. If they are parallel, that means they have the same slope, like 5x plus 2 and 5x plus 20. They're the same slope. They're increasing at the same rate. So they're never going to intersect. But more importantly, in this like subtopic, they are the same slope and just like go next to each other. So you just need to know that if it says parallel, that's just like literally saying like, okay, these things have the same slope. Perpendicular means you have a negative reciprocal. Let's say you have this line still, and then it says like, I don't know, line K is perpendicular to this line. Then what you do is you take the slope and you make it negative and you flip it upside down. So that's a negative reciprocal. You flip the fraction and then you turn it negative, or like whatever the opposite of your current sign is. So positive 5 turns into negative 1 over 5x. And you can see this visually because it forms a 90-degree angle. This is by definition perpendicular. It forms a 90-degree angle. You can't really fully tell in Desmos, but it looks pretty similar to a 90-degree angle. And also you literally know because of the slope. If you know this, you're fine. But also visually, if you want to look at it, they're going to look like a 90-degree angle. Now, let me do another example. Let's say like negative 1 over 9. The negative reciprocal would be flipped, so 9 over 1, so just 9, and then positive, because you turn negative to positive. You flip the sign. Let's do a couple more examples just to make sure you know this specific process. It's very important. So 1 over 3, negative 2, and then negative 100. Do all of these and find the negative reciprocals. Pause the video, and here we go. So this would turn into flipped, so 3, and negative, so negative 3. Negative 2 would turn into positive 1 over 2. And then negative 100 would turn to positive 1 over 100. So these are all the negative reciprocals, and I can show you this visually because they're all going to form 90-degree angles. This one actually might be pretty hard to see, but this is a 90-degree angle. Maybe I'll show you negative 2x and 1 over 2x. This is 90. You get the point, okay? So negative reciprocal, also 90-degree angles. Okay, let's do a couple examples. This one says, in the xy plane, line M passes through this 1 point and is parallel to this equation. So let me stop here. We have 1 point, and we're given the fact that this line M, is parallel to this equation right here. So if it's parallel, that means the slope is also 3 over 5. By the way, if you don't know, the slope is going to be the thing that's attached to the x value. So 3 over 5 is our slope here. Therefore, if our line M is parallel to that, then the slope is also 3 over 5x. So I'm probably going to use custom regression here. Now, line M also passes through this other point. What's the value of k? This is exactly like the example I did at first. And what we're going to do here is use a table and plug in the point, and then use a custom regression. You don't really know anything right now, but you do know that y1 is going to be equal to 3 over 5 x1. And you just don't know what the b value is, but you have this point right here. So let's say plus b. So therefore, b is negative 2.2. So this is our line right here. It's 3 over 5x minus 2.2. So that is our line M now. Because, once again, I use custom regression with this point, and then I use the fact that this line is parallel to line M, which means the slope is the same. So if the slope is the same, I'm going to say, okay, this is 3 over 5x plus b. B is a y-intercept of this function. You just do plus a constant, right? So now we have this graph here, and we need to find the point of k comma 5. The y value of that point is 5, right? So let's say y equals 5, and look where they intersect. And the x value is 12. So the answer of 12, or the answer of k is just 12. That's it. So once again, we're given 1 point. We're given the slope because it says it's parallel to this line. And then we have to find this point that it goes through. That's it. It's literally just k. Or 12, I mean. So yeah, if you have any questions, just shoot me a DM. Next one. Line M is defined by this equation. Line N is perpendicular to line M. What's the slope of line N? This one's pretty easy, honestly. We're given the slope of this, which is 9 over 4. And it says line N is perpendicular to that line. So perpendicular means negative reciprocal. We make a negative and then flip it. So instead of positive 9 over 4, it'll be negative 4 over 9. So the answer is just negative 4 over 9. That's it. You can put this in as a fraction or a decimal. I think the decimal would be negative 0.444 repeating, if I'm not mistaken. Yeah, so either one works. But you just put 5 characters. Next, it says line R is defined by this equation. Line S is perpendicular. What's the slope of line S? We have this weird equation. We could solve for the x value, like in slope intercept, but that's too hard. We're given MCQ, so this is going to be a lot easier just to like plug it in. So here's what I'm going to do. I think like, by the way, you want to get into like a prediction process. So I want to predict what I'm going to do first. I'm going to graph this equation, and then since I have the slopes as the options, I'm just going to plug all the slopes in to like an equation and see which one forms a 90-degree angle, because that's perpendicular by definition, right? So you want to type in the given equation, minus 3 over 4y plus 18 equals 0. So this is our slope here. We want to form a 90-degree angle. That would be perpendicular. So I'm going to say negative 8 over 27x. Is this perpendicular? No. That's an x. That is not a 90-degree angle. This is like way bigger than a 90-degree angle. That's definitely incorrect. B is this. This looks pretty good. I don't think I'm going to beat this one, honestly. This looks like 90. Let's check the other ones. 8 over 27x. This is parallel. That's completely incorrect. And then D, this is not 90, not even close. So the answer is just simply going to be B here. Because once again, it's perpendicular because it is 90 degrees. That's it. So just B. Easy. Now, last question. This is on one of the Blue Book tests. In the given pair of equations, C and D are constants. So we have 2 constants here, C and D. The graphs are perpendicular. Which of the following pairs of equations also is perpendicular? So it tells me these are perpendicular. We have 2 constants here. So my main goal here should probably be to solve for C and D. Because if we solve for C and D, then we can just plug in the options and see which ones are also perpendicular, right? So let me solve for C and D. All you have to do here is fulfill the condition. The condition is that these are perpendicular. So just type them in. 4x minus 3y equals 8. And then cx plus dy equals 8. You just add a slider and then drag them until perpendicular. This is actually very good already. But honestly, just make it doesn't have to be perfect, by the way. Like here, let me show you. This looks pretty good. I mean, that kind of looks like 90. So I'm just going to leave it like here. Yeah, that's good enough, honestly. Just make sure it's not way off. This is pretty much 90. This is kind of like a brain rot way to solve it, but it's really, really easy. Sure, this is good enough. This is 90. So now all we do is find the ones that are also perpendicular. The mistake I see here is people just delete C and D. You need C and D to find these perpendicular lines because C and D are like your variables. You have to apply them to your options as well. They're applying to those as well. You can't just delete C and D. That makes no sense. You want to delete your original equations because now you solve for C and D. You don't need the old ones anymore. And just type in the options and see which ones are perpendicular, otherwise known as 90-degree angles. So 2 dy equals 8. These are not 90, not even close. That's ridiculous. So it's not A. B is a plus symbol, and that is 90, clearly. That is clearly 90, so the answer is B. Now let me just show you the other ones, what they look like. D is 2cx plus dy equals 8. That's not even close. D is this, and then this 4x plus 3y equals 8. That is terrible as well. So the answer is just B because they're 90-degree angles, which are perpendicular lines. That is it. So this is how you take down slope and parallel perpendicular stuff. It's pretty easy. You're just going to either use custom regression or just like logic, honestly, or graphing. It's always going to be graphing of some sort. It's honestly not that hard. You should never be getting these wrong. If you have any questions, just shoot me a DM, as always. And yeah, let's move on. All right, now we have this very specific type of question that a lot of people struggle on. And it's kind of understandable because it's a very weird question, but it's really, really easy once you practice it a little bit. I did one of these on my YouTube, and a lot of people said I was wrong because they have the wrong process. So clearly, a lot of people struggle on this type of question. Anyway, let's go over it. It's called equation display or function display, whatever. Basically, the giveaway is when it says like, which of the following forms of something displays this as this, right? It'll be like, which of the following forms of the equation displays the maximum as a constant or a coefficient, whatever. So you literally need to find the thing they're asking for, like the maximum or the minimum or f of 2 or something, and then literally look for that number inside of the function. So let's say the maximum is 5. You literally look at the option and see which one has 5 in it. That's it. You don't do anything else. Like you don't do any algebra or anything. You just look at the number. Is it in the function? Yes. Then it's the right answer. That's it. So let's go over the like exponent stuff. If you have a base, that is the number with the exponent. So for example, a times b to the x power. The base here is the thing in the parentheses. This controls the increase or the decrease. Like if it's 0.5, it's decreasing. If it's 1.5, it's increasing. That's what controls everything. Now, the coefficient is the number being multiplied by. So like if you're multiplying something by something, the coefficient is the thing you're multiplying by, right? So in this case, the coefficient would be a. So for example, let's say, I don't know, we determine that the maximum here is like 2. Then you're like, okay, which of the following functions displays the maximum as a coefficient? Well, this one does because it shows the 2 inside of it. Anyway, lastly, fulfill all conditions if applicable. If they say like x is bigger than 0, you have to be evaluating from 0 onwards, not before that, okay? So if it says like x is bigger than something, make sure you're evaluating the graph from that point onwards. That's it. Let's do an example. This one says function g is defined by the given equation. Let me make sure you guys can see this fully. There we go. And which of the following equivalent forms of the equation displays the maximum value of the function as a constant or a coefficient? So you have this equation, and we need to find which of the options displays the max as a constant or a coefficient. So literally find the max of this function and see which one has the number in it. That is it. It's literally like so brain rot. G of x equals negative 4x squared plus 32x minus 55. The maximum here is going to be 9. Maximum value is y. The value of the function is the y value, okay? So maximum here is 9. So which one has a 9 in it? C. C has a 9 here. It's just C. That's it. Because it displays it as a constant. I didn't go over this, by the way. A constant is a number with no variable. So like this is a constant. This is a constant. Yeah. So anything that doesn't have an x attached to it is a constant, like if you're adding or subtracting it. And yeah, once again, the max here is 9. So you literally say, okay, which one has a 9 in it? That is it. You don't do any other math or anything. A lot of people like jump ahead and do math and arithmetic after, but you don't do anything. Let me show you the exact question that was on my YouTube everyone freaked out about. So this one says the functions f and g are defined by the given equations here and here, where x is bigger than or equal to 0. So we're going to evaluate x from 0 onwards. Which of the following equations displays as a constant or coefficient the maximum value of the function it defines where x is bigger than or equal to 0? So technically here 3 is a constant, but usually it'll be like adding out here. And then a coefficient would look like technically 150 would be the coefficient, right? So you want to see the maximum of these functions and see which one shows that value as the as either number in the equation. So let's just type in f of x and find the max. That's it. 150 x plus 3. Keep in mind the maximum here is from x equals 0 onwards. So technically there's no like max here. It's going to infinity, right? But you're supposed to evaluate from 0 onwards. You can add a constraint here and do like curly bracket x greater than or equal to 0. And then it'll tell you that the max is 32.4. But I don't really do that. I just look at 0 onwards, which is the y-intercept, right? So the y-intercept is the maximum of this function within this domain. So 32.4 is the maximum. Do you see that in the function? I don't see anything. So 32.4 is not displayed. So 1 only is gone, and 1 and 2 is gone as well. Now g of x. G of x is 150 times 0.6 times 0.6 again to the x power. What's the max here? It's 90. Do you see 90 anywhere? No. Now, a mistake everyone makes here is they do 150 times 0.6 and like, oh, this is 90. This is the maximum. You don't do that. Like you have like no math. Just look at it. Is the number in it? No, it's not displayed. You have to actually do like manual work to find the number. That's not displaying it. That's just like doing math, right? So is it displaying the number? No, then it's not displayed. So neither are correct. So just 1 or 2, or neither 1 or 2, I should say. So literally type in the functions and see which one shows you the maximum or whatever you're looking for as a constant or coefficient. Sometimes it'll say base or coefficient. Doesn't matter. Which one has a number in it? That's it. Last one. Pause this and do it on your own if you haven't. Let's go. For the exponential function g, the value of g of 3 is m, where m is a constant. So I know g of 3 is m. Which of the following equivalent forms of the function g? By the way, this means all these are equivalent. They're all the same function, just written differently. Which of the following shows a value of m, so g of 3, as the coefficient or the base? So my goal here is to find m. In order to find m, I need to find g of 3, because g of 3 is m. How do I find g of 3? Well, by plugging 3 in for g of x. But what is g of x? All of them are g of x. They're all the same. They're all equivalent. So therefore, I just plug 3 into any of these and see which one shows that number as a number. That's it. So A, g of x equals 12 times 5 to the x minus 3. And then g of 3 is just 12. And by the way, just keep in mind, this does not matter which function you pick. Let me pick B just to show you, just to make sure you know I'm not lying to you, right? X minus 4, you still get 12. Why are we getting 12? Well, they're equivalent. So therefore, it doesn't matter what function you pick. You're still going to get the same thing, 12, right? So it doesn't matter which function you pick. G of 3 is 12, which means m is 12. Which one shows 12 as a base or coefficient? A does. You have 12 right here as the base. 12 is here, but it's 12 over 5, not just 12. So it's not D, it's not C, it's not B. A is the one that has 12 inside of it. That is it. No math needed. Just type the thing in, find your value. Sometimes it'll say like it increases by a factor of C, but it's the same thing. You just find that C value by doing some Desmos thing, and then see which one shows that number in the equation. That is it. It's a very like straightforward, kind of no effort process to see which one shows the number inside of the equation. That is it. So make sure you, I guess, don't confuse any of these things, but they don't really matter. You're kind of just looking for the number that's inside of the function. You don't really necessarily have to know the specific base or coefficient, but I would prefer you do. And yeah, that is pretty much it. So let me know any questions. Well, Scott, how do you solve these insanely hard problems? Because I feel like the SAT has insane problems that never have been seen on the question bank or anywhere else. Well, the answer is have a set process and never break your system, right? You need a set system for solving every problem. You should have no problem with solving questions if you follow the same like routine every single time. 1, know what you're solving for. You need to look at the question and say, okay, I'm solving for this thing. This is how I'm going to get there. Step 2, fulfill all the conditions. If it tells you x is bigger than 5, x has to be bigger than 5. You can't say x is 3. So fulfill all of your conditions. And 2, know what you're solving for, predict what you're looking for, how you're going to do it, etc. You should never ever get problems incorrect if you follow this process properly. Never go away from your systems, okay? Step 1, question 1, I should say. This one says the function h is defined by this equation where c and d are constants. In the xy plane, the graph of this thing passes through this point, and h of 24 is bigger than 0. Which of the following must be true? So we're given 4 conditions here, and we have to figure out which one must be true. We're given 2 points here, and I have an equation, so I'm going to use a table and then custom regression. And I'm going to change the equation to this format they give me, because they gave it to me for a reason, right? So type in the points, 49, 0. H of 24 is bigger than 0, right? So 24 is your x value, and your y value is bigger than 0. So let's say 0.1. Doesn't even matter. Regression it, export it. y1 tilde c square root d minus x. Perfect. And keep in mind, h of 24 is bigger than 0, but we don't know specifically what it is. So now I need to check the conditions. Which of the following must be true? Well, when the value of h of 24 is 0.1, c is bigger than 0. Let's say it's like 0.2, 0.3. if it's like very, very tiny like this, if it's like very, very small like this. So basically what it's telling you is h of 24 is always going to be bigger than 0. So this is like the smallest it goes, basically, h of 24. So what it's telling you is c is never going to be 0 or a negative number because it can't. As you go up, it's just going to get bigger and bigger and bigger. 1, 2, 3, 4, 5, 6, 7, 8. C is only going to get bigger. So therefore, immediately, your condition is fulfilled. C is bigger than 0 instantly, and it never goes below it. So therefore, A is the answer. Let's check the other ones. Is D less than 0? D is 49. It's not even close. It's way bigger than 0. This is wrong. Is C always less than D? Well, let's say this is like 8,000. C is bigger than D. So immediately, this is not true. C is not less than D, so this is wrong. What is h of 0? Well, we can copy this thing and change it to h of x. H of x is going to equal C right there, perfect. And so h of 0, it's 11,200. Is that equal to 49? Definitely not even close. So the only condition you fulfilled is A, because the other ones are not true, because I checked them with different values. So therefore the answer is just A, because I can't prove that incorrect. It must be true. It's true at all values of C. It doesn't matter. So that is it. Like I said before, I predicted. I saw the question. I'm like, okay, I have 2 points. I have an equation, so I'm going to do this thing. I'm going to use a table. I'm going to use custom regression. I'm going to fulfill the conditions. That is it. So make sure you do not fail your systems. Follow your systems to a T. Next one. This one may or may not have been on March, and a lot of people asked me about it. So certainly something that could show up again. Just be ready. This expression can be rewritten as this expression, where P and Q are positive integers, so whole numbers, or as this one, where R and S are positive non-integers. So basically, this thing is equivalent to that, or that, and R and S are non-integers, so decimals, and P and Q are whole numbers. So I want to solve for P and Q first. That's the easiest thing, because I know this expression is equivalent to this one over here, so I can just use a tilde, because rewritten as means equivalent to. So I'm going to plug the thing in, plus 15, and then set a tilde to 4x1 squared plus P, and then 2x1 squared plus Q. I have two expressions, and I want to simulate all the values for x. So I'm going to say x1 equals random 10. So now that we have x1 defined as random 10, we need to fulfill the other condition, which is that P and Q are integers. Right now, Q is not an integer. That's bad. So I need that to be an integer. Let's just say Q is 1. Let's set a slider. We're going to control the slider until both are integers and then just add them. That's it. Q is 1. P is not an integer. Q is 2. No. Q is 3, 4, 5. When Q is 5, P is 3. They're both integers. Therefore, your condition is fulfilled, and P plus Q is 8. That is it. All we did is plug the tilde in, fulfill the condition, and we got the answer right. If you did it at first and you just like did random 10 and you got 10 and 1.5, you got it wrong because Q is not an integer. You did not fulfill the condition. So like I said, make sure you fulfill all of your conditions. It's so, so important. Now this one says the function f is defined by this equation. The function g is an increasing linear function. In the xy plane, the graphs of f of x and g of x intersect at 2 points where r is less than t. When g of x is bigger than f of x, which of the following must be true? We have all these statements here. So I know f of x is 2 to the x power, and g is an increasing linear function. So I could say g is just something, because it doesn't tell me specifically what it is. Let's say 5x plus 20 or something. Doesn't even matter. Perfect. Now it says they intersect at 2 points, which is true here and here. You have to make sure you don't pick the intercept, by the way. It's right there. Cool. So we fulfilled that condition. And r is less than t. So the first point, therefore, is going to be this right here. This is going to be the first point, r comma s. So r is this. And then s is this. All right, perfect. Now t comma u is the other point. So this is t. And this is u. You can't copy and paste on the real thing, but I'm just going to do it anyway. Where r is less than t. Okay, perfect. So we just found all the numbers. It says when g of x is bigger than f of x, which of the following must be true? G of x is the black line. F of x is the purple line. So when g of x is greater than f of x is going to be when the black line is above the purple line, because that is the value of the function. Like the y value is the value of the function. So you want to see the like interval where the black line is bigger, which is just simply between this point and this point. Conveniently, right? So this is the interval where g of x is bigger than f of x. Now, which of the following must be true? I have everything fulfilled. I have both points. I have the conditions fulfilled. Which of the following must be true? Well, the x values of this interval are going to go from this right here to this right here. These are like the bounds. So let's look at A real quick. What is R? R is negative 3.9739. 3.98, sorry. So which point is that? It's right here. This is claiming that x is lower than r, but x has to be bigger than r by a little bit because the interval is going from this to that. So x cannot be lower than that because then it would be below the f of x function. So you need x to be between here and here. So this first condition is incorrect because x is not lower than r. Now, is x greater than t? T is 5.58, and x cannot be bigger because then at that point, f of x would be bigger because, like, look here. It's going to be bigger at that point, right? So that is incorrect as well. X is not bigger than t. It has to be less than that. R is less than x is less than t, okay? That's saying that x is between r and t. R is this right here, and t is this right here. This is true because the interval of the x values is between negative 3.9 and positive 5.5. So like when g of x is above f of x, the x value is between these 2 points. Those are the bounds. So therefore, this condition is fulfilled, and it's just C. And that is it. Now, let me clarify here. We plotted our stuff. We fulfilled all the conditions. We found the points. We found all the constants we needed. And then we just saw which condition must be true at all values. And I just used logic here. I'm like, okay, x cannot be bigger than t. This is like the biggest it goes. And x cannot be smaller than r because this is the smallest it goes as well. So it has to be C, so x has to be between these two boundaries, and that is it. So this is how you approach these advanced level math problems. Just never fail your process, predict what you're going to do, and fulfill all of your conditions, and that is it. If this guide helped you, just know this is only one piece of the puzzle of all of the content I teach in the blueprint. If you join, you get access to weekly calls with me and the rest of the group. You get practice tests, courses, question banks, and so much more. So if you want to stop piecing together random advice on YouTube and get the full system, including geometry, reading, grammar, etc., I recommend you join my group. I'm going to put the link down below in the description and subscribe for more.